Hi, everyone. Welcome to the tutorial number 4. And the speaker for this tutorial is John Rofano. John is a senior technical staff member and a DevOps champion at the IBM T.J. Watson Research Center, where he leads a variety of research projects exploring the use of AI and machine learning for accelerating application modernization to cloud. He is also an adjunct professor at the New York University Current Institute, where he teaches a master's class on DevOps and Agile methodologies. John has authored numerous patents, papers, and books, and you are going to like this. He's an accomplished musician and a videographer. So let's welcome John Rofano to deliver his tutorial.
Thanks, Carl. And thanks everyone for being here. It's really a pleasure to be with you today and kind of explore and go through a journey of the DevOps culture. I've got a lot of material from my course. There's actually 8 lectures from a 15 lecture course that I'm going to pack into 3 hours. Unfortunately, you can't get any credit for my course, but there's a lot of good stuff in there. It was tough to pare down. And, you know, we're going to go through this live. We're going to have hands-on. I teach my course with hands-on, 50% lecture, 50% hands-on, because I think doing is when you really learn. It's when things really sink into your head. So we've got a lot to cover. So let me get right down to it. So you may be saying to yourself, why for software engineers? And actually, the problem we have in the industry is that DevOps is often misunderstood. This, what I have on the chart here, is an actual dropdown from a major company saying, what's your job function? And somehow they missed the DEV in DevOps and thought ops was all the DevOps people do. And if you go out and you read the job postings for DevOps engineer, you could just like close your eyes, erase DevOps engineer, and put sysadmin, and the posting would read pretty much the same. The sad part is that they separated out in this job function software developers from DevOps, from ops, which means they missed the whole point. They haven't a clue what DevOps is. So hopefully by the end of 3 hours, I'm going to help you understand why this is so wrong. But really, a lot of devs think that as well. And so that's why I say this is DevOps for software engineers. Because when I teach my course, I tell my students, this is an advanced software engineering course. This is not an operations course. So I'm going to focus on the dev part of DevOps more than the ops, although we are going to do some ops. I like to call this zero to hero training. I assume you know nothing about the topic. You have to be a software engineer because it is kind of advanced software engineering, but you know how to program in the language, Python, Java, whatever, it doesn't matter. We're going to go through a workflow, right, that developers should be adhering to when they're working in a DevOps organization. So we'll go through the culture. We'll talk about infrastructure as code. It's the first thing we'll put together. And then we'll go through cloud native and microservices and 12-factor, do some test-driven development and continuous integration. And it's just a lot of stuff. But hopefully you're going to have a lot of fun doing it. So some assembly required. If you're going to follow along, I assume you're watching this hopefully on a computer, but you might be on your phone. If you are, it's going to be a little hard to push changes on your phone. But as long as you have a computer and access to download the boxes and the software we need and a GitHub account, that's really all you need. PC users might have to do a little extra to get VirtualBox working. But the key thing here is, you know, I like to say, you know, from the song Coca-Cola, words I can't take it anymore, right? Pepsi, Coke, paper, plastic, you know, Windows, Mac. There's just so many choices, and really when you have to choose and when you have to be cognizant of where you are, it's just so little productivity. So we're going to fix all that today. We're going to use Ubuntu Linux to do all of our work. And this is what I do with my class, right? We do all of our work in Ubuntu Linux because some students have Mac, some have Windows, some have Linux, and one even had a Surface Pro, worked fine. So that means there's some prerequisite software. If you're going to follow me along today, then there's some software to install. So the way this is structured is that I'm going to give you some homework to install software, and then I'm going to present some topics to you. And then once all the software is installed, we can go do things together. So what problem am I trying to solve? The same problem I have here, right, in a conference is the same problem I have in school, but mostly the problem I have in my development environments at work, right? How do I get all the developers in the same environment? How long does it take to onboard a developer? If they have to read some book and spend half a day or 2 days or 3 days, getting all the software installed, it's crazy, right? You just can't do it. But what we're trying to avoid is, works on my computer. I don't know why it doesn't work on yours. And so the way you fix that is give everybody the same environment. So that's what we're going to do, right? We're not going to document. I didn't give you any prereqs. Please, here's 20 steps to go install stuff. We're going to do it right now. We're going to do it together. I'm going to use Vagrant, VirtualBox, and Docker, right? Kind of this trinity of software where VirtualBox is going to be our hypervisor, Vagrant is going to automate stuff, and Docker is going to provide all of the middleware. So without further ado, bring up a browser and go to github.com/Refrano, that's my last name, and then DevOps-workshop-2020. So that's github.com/Refrano/DevOps-workshop-2020. If we go look at what that is, that's this one right here in GitHub. So you'll see it's the DevOps and Software Engineers 2020. And in the README here is a bunch of links. And these are the links. So while I'm doing my DevOps culture talk, your homework is to go install the prerequisite software. It shouldn't take very long. So let's just go click on that now. So here's install prerequisite software. Now, if you're on a Mac, hopefully you use Homebrew. If you don't use Homebrew and you're a developer, you should be using Homebrew, right? Because this is the package manager that Apple forgot. And so if you have a client to install it, it's very easy. Just swipe, just swipe this here and paste it into a terminal, right? Into a bash shell or a Z shell or whatever shell you have. And then to install the software, it's just these commands. Let me make this a little bit bigger for you so you can see. It's just these commands. So it's brew install Git if you don't have Git. Hopefully you have Git if you're a developer. Brewcast install VirtualBox, Vagrant. Those are the only ones you have to have. VirtualBox and Vagrant you have to have. I would strongly recommend a programmer's editor. If you like Visual Studio Code, it's a great editor. I just switched from Atom this year to Visual Studio Code. I'm like falling in love with it. Yeah, I have to admit, I'm attracted to new, shiny new things, right? So this Visual Studio Code is my shiny new thing this year. And then Postman is kind of optional. We'll do some curl commands, but Postman helps you post to a REST API. Now, if you're on Windows, then you have to do a manual install, but all the links are here. So you click on that when you go to VirtualBox, go to Vagrant, download them, install them, Visual Studio Code, Postman. If you don't have Git on Windows, there's Git. And if you do have Git, it has a built-in SSH client. So let me just show you a little bit more about this. I have some more charts on this. So Mac, I strongly recommend Homebrew, but if you don't want to use Homebrew, you can certainly manually install the way Windows users can. So Mac, you're done. Windows has a couple more steps to do. So go to VirtualBox, find the version, latest version for Windows hosts or for OS X host if you want to do it with Mac, and download it and install it. Then go to Vagrant. The links are in the README, and find the one for your host, download and install it. Now, if you don't have I guess Windows now has the subsystem for Linux, and a lot of this stuff is in there. Now you've got bash shells in the subsystem for Linux. But if you don't, you can, when you install Git, there's an option here in the Git setup, the third option. The first one is the default, which says use Git from Git bash only. The third one says use Git and optional Unix tools from the Windows command prompt. And if you select that one, it will give you everything you need. You'll get an SSH client. You'll get all the stuff that Windows needs to talk to Unix computers. So that's kind of key. If for some reason you're on Windows, Lenovo does this a lot. They ship their laptops with this VDT thing turned off, and then VirtualBox doesn't work. And so you may have to go turn that on your BIOS to get VirtualBox to work. Hopefully you don't, because it's not fun playing around with the BIOS. But if you have trouble with VirtualBox, that's the reason. So go install them. Once you have them all downloaded, install VirtualBox first, then Vagrant, and then any other prerequisite software that you want to install. Okay, so that's your homework. Let me tell you a little bit about what's happening as you install this software. So again, this is like one of the tenets of DevOps is to not do things manually, is to automate everything. And infrastructure as code is a term we use to mean I don't want to be manually creating my infrastructure, manually creating virtual machines, creating Docker containers, creating whatever I have to create. I want to specify in code how to go create these things. And I want them to be done automatically. And not only for speed, but for repeatability. So it happens the same way every time. And so if you're not familiar with virtual machines, just quickly, right? Virtual machines are little computers running on your computer, right? So there's a piece of software called the hypervisor that emulates the real hardware of your computer. So you've got your hardware, your operating system, then you got a hypervisor, and then you could spin up Unix, right? Linux or something, Ubuntu. You could spin up Windows. You could spin up, a Red Hat version of Linux. And then you've got a whole operating system, all your binaries and libraries, and your application running on top of that, right? So you could have multiple of these virtual machines, right? Kind of virtual hardware. And so the physical machine is up to the hypervisor, and then virtual machines on top. So VirtualBox is a hypervisor. That is exactly what it is. It runs on Mac OS, runs on Windows, runs on Linux. That's why I like to use it. It's free. Another reason why I like to use it. It's similar to VMware Workstation or VMware Fusion or any of the paid for, Parallels Desktop on the Mac, any of those things. They're all hypervisors. They all work with Vagrant. We're just using VirtualBox because it's free and it's easier to do that today. Vagrant then is a developer's tool. While Vagrant can provision on AWS or SoftLayer, it does that for developers. If a developer needs some VMs in SoftLayer or some VMs on Azure or AWS, Vagrant can instantiate those VMs, configure them for you, and then get rid of them. You wouldn't want to use that in production. HashiCorp that creates Vagrant has something called Terraform, and Terraform is the production version, if you will, of Vagrant. Vagrant is a developer's tool. But it allows you to create these reproducible environments. So very, very critical in getting all your developers to have the same environment. So Vagrant is the puppet master, right? Vagrant controls everything. It's the one pulling all the strings, right? Give me a virtual machine, install this on top of it, configure the network this way, and then it's identical on everybody's machine. I mean, this is great for me in the classroom. I've got 45 students, right? And they're all, hey, works on my machine, doesn't work on your machine. And so this is a great neutralizer. And it's and also for developers, right? And so with all this infrastructure is coded in this thing called a Vagrant file. And then I just say Vagrant up, and it brings up the environment. Vagrant destroy, it destroys it. Vagrant halt, it puts it to sleep. Vagrant up, wakes it up again, right? So this is infrastructure as code. So here's an example Vagrant file that you can see big. It's Vagrant is written in Ruby. And so this is Ruby syntax, for those of you familiar with Ruby. And it says, here's a box I want you to start with. What's the box? The box is an image, right? When you install Ubuntu, you start with an ISO image of a DVD, and you install it. So this is a pre-configured image, kind of like AMIs in AWS. It's an image you start from, and then I want to do my networking on top of it. Here I'm giving it an IP address. This 192.168.33.10, that is, we're going to use that a lot today. That's going to be the network address of the VM, that if we want to get to that VM. And then here I'm saying, give me 1 gig of memory, 2 CPUs, and then go provision some stuff. Install Git, Python, pip. If we want to look at what's really going on, this is the real Vagrant file I have open in VS Code. So it's forwarding a couple of ports, 8080, 5000. It's asking for a little bit more memory today because we're going to do Kubernetes. So it's asking for 4 gigabytes of memory. So hopefully you have 4 or more on your laptop. It's copying in some, my Git config. So Git knows who I am when I'm in that virtual machine, and some SSH and my Vim RC. And then it provisions all this Python stuff, and then it goes off and it creates a Python virtual environment, activates that environment, does a pip install to install all the packages I need for Python. Like, you'd have to do this manually as a developer every time you want to use this thing. All right, so that's what I tell my students. If the thing's been working great for a week and then one day it doesn't work, don't spend too much time debugging the VM, right? Because it's simple to just say, look, I don't know what went wrong. Vagrant destroy, Vagrant up, brand new VM comes up, configured perfectly like the first day, and you're off and running again. Then I provisioned Docker, so we're going to have Redis in here and a Python image that we're going to build our image from. And then it installs a tiny version of Kubernetes called microservices. I was doing microservices. I was playing around with Helm, but I decided it was too much to put in the tutorial, so I commented it out. But if you want to install Helm, that's Helm. And so that's what this is doing. So it's bringing all this stuff up on everybody's laptop the same, so that when we're ready to do the hands-on tutorials, we're all going to have the exact same environment. It's not going to be, oh, I've got Anaconda Python and I've got some other Python. We're all going to have the same thing. This will make your development team, your research team, whatever team is working with software, so much more productive, because you can onboard people quickly. You can get back to steady state quickly. I've been using it for a long time, and I really highly recommend it. Okay. So what's in that repo? So in the repo that you're going to clone, and we're not cloning it yet. We're just installing software now. Has Python 3 environment, as you saw, Redis in a database, microservices, and some various ports forwarded. So the goal here, we want to be, as developers, as researchers, we want to be working at the summit of innovation. We do not want to be drowning in the sea of technical debt, right? And technical debt is, I have to re-provision my machine, I got to re-provision my database, I got to anything or do anything the first time, right? So this is, how can we take all the technical debt that's in our lives that we have to deal with and use infrastructure as code to wash that all away and get to, the summit of innovation, where we want to innovate and not be setting up environments anymore. So that was kind of the first, and I do this as a whole lecture in my class because we play with Vagrant. I show them different ways to bring it up and all that stuff, writing Vagrant files. But I wanted you to get a flavor of why we're using this and how valuable it is, right, to get your development teams, your research teams up and productive very quickly. Okay. So DevOps. DevOps culture is probably the most misunderstood part of DevOps, although we've been preaching it for years, and we think that everybody kind of got it. Then you go see like that dropdown, and actually that dropdown I cut and paste like within the last week, right? So that did not spark this whole thing, right? But just within the last week, I had to sign up for something, and it had that drop down. I'm like, this is perfect for my talk. People still don't get it. So let me take you through this. There's been some disrupting trends, right? Social coding revolution. I have to update this every time. I only got numbers since 2018, when GitHub said, 100 million plus repos on GitHub, like, mind blowing. So open source is leading innovation. The whole cloud native movement, Netflix and Airbnb and Etsy, and then the enterprises who are trying to do a digital transformation, right? They're trying to reinvent themselves, but they've got lots of technical debt and lots of legacy to deal with. And actually, that's one of the things I do in my day job at research, is using AI to figure out, how do we modernize that? Can we use AI to help modernize applications, these big monoliths, into microservices, right? It's a real problem to upgrade and make all the software new again for these new environments. So consider this. What if you could fail fast and roll back quickly? Then the impact of failure would be minimal. You can minimize your blast radius, right? Rather than worrying about having to reinstall a whole thing, you could just put something out there, and then it doesn't work, flip the switch, have the old one back out there, and not have to like uninstall, back out, all that. That would be cool. What if you can test and market instead of analyzing, right? We sit and say, what with a customer like this, maybe with a customer like that. Well, Facebook and Twitter, they're doing this to you all the time, right? You may see something on Facebook, and you'll say to your friend, hey, did you see that new thing on Facebook? And your friend's like looking at you like, what are you talking about? They were A/B testing you, and your friends were the Bs, right? And you were the As. So these companies don't second guess what a customer is like. They put it out there. Did they click on it? Did they do whatever behavior we thought they'd do, right? And they measure in market. I mean, that's very powerful to be able to do that. And what if your application design allowed individual components to be replaced? Now you don't have these big bang releases where it's all or nothing at all. I can just be changing things constantly all the time. So agility is the goal, right? Experimenting in market, moving quickly, gaining value quickly. So there are kind of three pillars to agility. There's DevOps with its culture and its automated pipelines. Everything is code, right? Infrastructure, everything is code, these immutable infrastructures. Then there's application design and microservices, right? So loosely coupled RESTful APIs designed to resist failures. And the third piece is, how do I take all these microservices and get them out there? And that's containers, right? Having this portability, developer-centric ecosystem with containers. So I like to call this the perfect storm. Any one of those technologies is, kind of cool on its own, but I put together DevOps for speed and agility, and then microservices for these small application deployments, and then containers for ephemeral runtimes. And there's just something special about putting those three together. So that's what you're going to explore in the next 3 hours, is using these technologies to form that perfect storm. So a quick background on DevOps. It started back in 2007 with Patrick Dubois. He's often quoted as being the father of DevOps. He's like, why can't Dev and Ops just work better together? And Andrew Clay Schaefer, a year later, had a birds of feather that he didn't even attend, but Patrick did, and Patrick went out and looked for him. And that kind of started something. That was the spark that started. But what really caught people's attention was in 2009, John Osbaugh made now his famous speech, right, at the Velocity Conference, 10 deploys per day DevOps cooperation at Flickr. And that's when people's eyes really open. Now, if you haven't been to a DevOps days, they started in 2009. Patrick Dubois started them back in Ghent, in Belgium. I just went to the one in New York before the pandemic closed everything down back in like January or February. I forget when it was, probably January. And it's just all incredible like minds together. And even though we're all remote, they are all over the world, right? So this is, 10 years of DevOps days. Get yourself to a DevOps Days conference. Really, really going to learn a lot from it. So this was the turning moment. John Osbaugh, 2009. And you can go, there's a link there on Twitter. Please don't watch it now. Him and Paul Hammond talking about 10 deploys per day. And people like, 10 deploys per day? That's crazy. How could you deploy your whole website 10 times a day? Well, he wasn't deploying their whole website 10 times a day, right? They had a different way of designing things. They were deploying something, 10 times a day, but it wasn't everything 10 times a day. Then a couple of years later, Etsy, made a post on their blog about, 76 unique individuals deploying by 63 different folks, a total of 517 times. I did the math. That 25 minutes is my calculation is down at the bottom. But now Etsy is getting on board just like 2 years later. And so people are saying, well, these are mythical companies. These are the startups. These are the unicorns, man. This could never happen in an enterprise. No way, no how. Enterprises, big, slow, lumbering giants. Ain't going to happen. Not here. And then in 2016, at the DevOps Enterprise Summit that Gene Kim started just, I think, 2 years earlier, companies like Ticketmaster and Nordstrom and Target and USSA and ING, major banks, right? Major insurance companies, entertainment companies, they're singing the praises of DevOps. And people are starting to open their eyes. Now, check your watch. That's 4 years ago. People are starting to open their eyes. 98% reduction mean time to recovery, 20% shorter lead times, full stack deployments, 3 months to minutes. And USSA, right, from 28 days to 7 days, right? From a month to deploy something to a week, that's pretty achievable. But big enterprises were getting these benefits. And the question is, how are they doing this? And the answer is, they've embraced the culture. It wasn't a tool, it wasn't just some practice they adopted. It was the culture. So Patrick Dubois back in 2009 said the term development operations, DevOps, is an extension of agile development environments that aims to enhance the process of software delivery as a whole. Just how can we deliver software better? And then it answers it begs the question, why can't Dev and Ops work together? And so, Dev and Ops, they're different. They're just different, right? The Dev's a little bit weird, sits closer to the boss, thinks too hard. The Ops guys, they run around with their hair on fire, pulling levers, easily excitable. Yeah, they're just different people, right? Dev and Ops. And then we've got this crazy waterfall development. Like, I'm going to talk more about this later, but all these handoffs, and you can only go one way. It's really hard, to swim up a waterfall. And if you make mistakes later on, well, it's too bad you weren't omnipotent up front, because that's going to cost you a lot. So the problem with this is long time to deliver it. The teams have no idea what impact they're having on each other because they don't even work together. And the people furthest from the code, the poor ops people, they got to maintain the thing, right? I mean, it's lunacy. It's really crazy. So I love this chart from Andrew Clay Schaefer. He called it the wall of confusion, and it's true. And it's the measurement system, right? Devs are measured on wanting change, get change out there. Ops are measured on stability. Stability is like, no, 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 please don't change anything, right? They're diametrically opposed. I am measuring these people report to the same executive somewhere in the company. We're measuring them on things that are diametrically opposed. How can we do this? I call it the Kobayashi Maru for my Star Trek fans. It's the no-win scenario, right? So, ops thinks, the dev teams are throwing dead cats over the wall. They're manually making changes. They have no back out plans. They don't test, right? The devs are saying these ops teams, they're all in nothing changes, Windows in the dead of night. They're the first people away from the code, and they cut and paste from run books. They have no idea what's going on. Well, silos, my friend, breed apathy. And you shouldn't be surprised that silos breed apathy. Because when you abstract people away from the consequence of their actions, that's what happens. So if the website works, the devs get the praise. If the website is down, ops gets the blame. Did I mention the Kobayashi Maru? So then you say, well, but we're agile. We've been doing agile for a long time, right? We're self-organized, cross-functional. We have adaptive planning. We're continuously improving, right? Responses to change. Working in small teams, dedicated, co-located. Well, we're not co-located now. We're kind of far away from each other now, but the co-located was cool when it was working. Cross-functional, self-managing, all good stuff, right? Working in these small sprints, pushing stuff out every 2 weeks. Life couldn't be better. Well, there's a problem with this. And this picture I did not create, but I was on this project. Right? We were an agile team. We started in January on a new project. By, I think, February, we had code ready to ship. We asked the ops people, hey, back then we needed VMs. Even though we're using Docker, we're deploying them on VMs. Oh, well, you need to open a ticket and you need to wait and you get to put in the backlog. And the code didn't get deployed until September. I left the project in December. I had had enough. So agile isn't good enough, because if you can't do that last mile, if ops isn't being agile, then all agile does is make the devs wait. And this is what results in two-speed IT, right? The developer says, I need some resource for a project. And the ops guy says, oh yeah, open a ticket. And the dev guy says, nah, I got a credit card. Nah, never mind. Right, we'll go around. And that's how shadow IT is born. So I like to call DevOps agile for ops, or agile with ops, but it's making the ops people as agile as the development people are, right? It's agile for everyone. So what is DevOps then? DevOps is acknowledging that these siloed towers don't work. And in order to break them down, we have to change our culture. We have to change our application design. We have to change and automate everything that we're doing manually. And we need a programmable platform, to get all this stuff out the door, right? We can't be waiting weeks for a test system to get, created lovingly by hand. And then you never broke it down because it took you weeks to create. No, I want to be able to instantiate these things in minutes, hours, and then use them for as long as I need, and then break them down. And when I need them again, I fluff them back up again. So DevOps has 3 dimensions: culture, method, and tools. But the most important of those is culture. This is what has the biggest impact. Atlassian says culture is the #1 success factor in DevOps. Building a culture of shared responsibility, transparency, faster feedback is the foundation of every high-performing DevOps team. So how do we change a culture? Man, culture is like who we are. Culture is ingrained in everything we do. Countries have cultures. Companies have cultures, right? Nationalities have culture. I mean, culture it's so ingrained in us. It's so hard to change culture, even culture of a company, right? So I thought about this and said, well, really, to change a culture, you got to change the way people think. You got to change the way they work. You got to change the way they're organized, and you got to change the way they're measured. So you got to change the way people think. You got to think DevOps. You got to think social coding. We're going to go through social coding today in our 3 hours. Behavior-driven and test-driven development. I'm going to go over test-driven development. Not enough time for behavior-driven development. Working in small batches, really critical. Building minimum viable products so that you can gain insight, right? And then failure leads to understanding. I tell my students, every failure is a learning opportunity. I don't even, the first half of the semester, I let them mess up and fail, and I don't grade them hard on it because I want them to be able to learn and fail quickly and learn from it. And then when they should know better, I grade them a little harder. Hard to do in a college setting, but really you want a blameless culture, right? Failure leads to understanding. It's an opportunity to learn something. So social coding, right? Everything's in a public repo. You discuss changes, you create issues, you can fork the code and work on someone else's code. You can create a branch if you're part of the team and make pull requests. That's what we're going to be working on today. Minimum viable product is probably the most misunderstood thing in corporate America. I think all the startups get it. But in corporate America, people think, oh, that's your first phase one of your project is MVP one, right? And give me your first 3 MVPs. And what you get what's on the top, right? I want a red coupe, and they give me a wheel, they give me a chassis. I can't do anything with it. A lot of the upfront things aren't very good. But if you really understand that an MVP is the smallest, cheapest thing you can build to prove your hypothesis and learn something from it, then you start like the guy on the bottom. Well, you add to that red coupe. I gave you a red skateboard. And they're like, oh, dude, it's a skateboard. It's not going to compete with a car. What are you talking? You go, shh, no. We're testing the color red. How do you like the color? Is that the color red you want? Because that's the hypothesis we're testing, that this is going to be the color that you like. Well, yeah, the red's pretty cool. But I can't steer the thing. We'll work on the next MVP. Then you give them something to help them steer it. But I can't go too fast. We'll give you pedals, right? To let it go a little faster in the next MVP. And then somewhere along the line, they're driving that motorcycle and they're realizing, I like the feeling the wind in my hair. And they're like, you know what? I want a convertible. That is what being agile and listening to your customer and going on the journey with them, being responsive to their changes, because the customer probably doesn't know what they want in the beginning anyway. So you'll notice the customer on the bottom has a bigger smile than the one on the top, right? But it's that journey, to take that journey with the customer is really, really important. Thinking cloud native, microservices, 12-factor. I'm going to do a whole talk on this. Microservices are, creating these small services that are communicating via REST APIs, each with their own bounded context. So since failure is inevitable, you got to architect your software to be resistant and to scale horizontally. So you got to design for failure. I'm going to talk a little more about this later, but doing things like creating circuit breaker patterns and bulkhead patterns. You got to think continuous automation. We're going to talk about continuous integration and continuous delivery in this talk later. Now, automation, as I said, is not just about speed, it's about repeatability. And think about continuous improvement, right? You want to get these feedback loops where you can put stuff out there, see if the customer likes it, and then iterate on it, right? If you're iterating and never deploying, you have no idea whether the customer's going to like it or not. You never gave it to them, right? So you can't just iterate internally and never deploy it. You got to get it out there. You got to deploy it and get feedback from the customer. John Allspaw, when he was the CTO at Etsy, said being able to recover quickly from failures is more important than having failures less often. So how do you change a culture? You got to change the way people work. We have been working the same way since the Industrial Revolution. If you think about it, it's called Taylorism from Frederick Winslow Taylor. It's, we hire some managers, they hire people, they tell them what to do, they measure if they did it, right? It's this command and control, top down. And, when you were building, assembly lines of cars, Taylor was very smart. He realized that if you built the whole car bespoke, it took a lot longer than if someone just put wheels on all day and put doors on all day. And so he realized this assembly line could really, really speed things up. Henry Ford, of course, had the first assembly line. And so that worked really, really well. But the impact of Taylorism on information technology is what you see in Waterfall. We've got project managers and architects and developers and testers, and they hand things off to each other as if building software was an assembly line. But there's a problem with this. Look at those guys putting the cars together. What's all around them? Parts. Parts. Wow. Most of the parts I need don't even exist when I'm doing software development, right? Some of them do, right? I buy some libraries and stuff, but I don't have all the parts. So software development is not like an assembly line in that, first of all, I don't have all the parts. Second of all, I'm not making 10,000 applications. I'm making one application. I'm not scaling up to make 10,000 Model Ts. I'm making one application. So you've got to realize that DevOps represent the reincarnation of craft work. Software is bespoke by definition. If it wasn't, we'd buy it off the shelf, right? The fact that we can't buy it off the shelf means it's bespoke. We're creating this one-off thing, right? And so you can't apply assembly line tactics to it. You got to stop doing that. So Taylorism, not appropriate for craft work. Automation's resolved a lot of problems. People power requirements have been lowered. I mean, it's not good for knowledge workers. The other problem we have is we treat software engineering like civil engineering. And we see this all the time. And so, this project model is fundamentally flawed. If you go to build a building, you have an architect designs the building, and then they pass it on to the construction workers and they build the building, and then they pass it on to the maintenance team and they maintain the building. And unless you're in California, the ground under the building doesn't go anywhere, right? But when you build software, the operating system's constantly getting patched, the database is getting patched, the ground is moving under that software. It's not like a building, it's a living, breathing thing. And you have to maintain it, and you have to understand that things are going to change. And so you have to have people there, architects there all the time, engineers there to tweak and change this. So you have to get more of a product model rather than a project model. Rather than people move on, you have people stay with it, right? Very, very important to be successful. So DevOps facilitates teaming, agile development, automate relentlessly, smaller releases, right? It's this clash of cultures. Instead of manually configuring things, you automate the configuration. Instead of bespoke infrastructure, you have ephemeral infrastructure that's infrastructure as code, right? So you really want to turn all this stuff on its head and make it more efficient. And immutable delivery, we're going to learn about Docker and Kubernetes at the tail end of this this module. And so these are technologies that help us do the immutable delivery that we need. So DevOps is about breaking down these silos, working as a single team. So how do we change a culture? We got to change the way people are organized. Conway's Law, most of you are probably familiar with Conway's Law, right? Any organization designs a system will produce a design whose structures a copy of the organization's communication structures, right? So you ask 4 teams to build a compiler, you get a 4-pass compiler. You shouldn't be surprised you got a 4-pass compiler. Yes, 4 teams to build it. And this is how our software is structured. We got DBAs, we got app teams, we got user interface teams, and they build 3-tier applications. And we shouldn't be surprised they build 3-tier applications because they stay in their little teams. And so in order to take advantage of this new application design in DevOps, you've got to have your teams around business domains, right? It's like an account team, a personalization team, a warehouse team, and they have end-to-end database, UI, the whole thing, right? So you really have to restructure your teams around these business domains to really take advantage of DevOps. If you're not going to do that, you're not going to get the full benefit. So this is a harken back to the opening slide, right? This is why I call my talk DevOps for Software Engineers. So Dev and Ops, traditional enterprise, wall of confusion between them, business as usual. Then there's companies that think DevOps is a team that sits between Dev and Ops, right? And if you look at the job hirings, you'll see, oh, work with the devs, work with the ops. Again, they kind of didn't get the memo, right? That DevOps is about breaking down the silos. Then some companies think DevOps is something the devs do and the ops just go about their business. Other companies, this company that I had to drop down, thought that DevOps is something the ops people do and the devs go about their business, and really DevOps is something everyone does. It's a blending of development and operations, one name, one team, one set of metrics, okay? So it becomes a company culture. You would not say, oh, my company's agile. Really? Oh, you guys, oh yeah, we have an agile team. We have the agile team. They're over there. They make us agile. They're the agile team. You wouldn't do that. But DevOps is the same thing. You don't have a DevOps team. DevOps is what you become. DevOps is the culture, right, that you turn your company into. Really, really important to understand. So there's no such thing as a DevOps team. That's an anti-pattern, right? You want, shared consciousness with distributed local control. Everyone understands kind of the overall goal, but then distributed, everybody locally is in control of making their own decisions so they can make them quickly. Jess Humble says bad behavior arises when you abstract people away from the consequence of their actions. This is a true story. This is a company that had a lot of bugs in their code. They didn't have a QA team. And so they hired a QA team and they found out the bugs went up. And they're like, how could the bugs go up? We hired a QA team. It's because the developers felt it wasn't their job to test the code anymore. And so they stopped. Oh, that's the QA team does, right? You abstract people away from the consequence of their behavior, and that's what you get. Not always a good idea. Actions have consequences, right? You've got to make people understand that. So if you can't have a cross-functional team, have the devs rotate through the ops team, have the ops attend the devs stand-ups, put a pager on a developer. You only have to call a developer out like once at 3 a.m. and they write on Sunday, and they write better code on Monday. So, have them feel the pain. Werner Vogel from CTO at Amazon says, you build it, you run it. That's how he runs his teams, right? They run things end to end. There's no dev and ops. It's just the team, right? So how do you change a culture? You got to change the way people are measured. This is from the Academy of Management Journal back in 75, right? The folly of rewarding for A while hoping for B. Companies do this all the time. I don't know why they get it. Maybe they didn't read the journal. But whether dealing with monkeys, rats, or human beings, it's hardly controversial to state that most organisms seek the information concerning what activities are rewarded and then seek to, or at least pretend to do, those things, often to the exclusion of activities that are not rewarded. The extent to which this occurs, of course, will depend on the perceived attractiveness of the reward offered, but neither operant or expectancy theorists would quarrel in the essence of this notion. You get what you measure. So you measure widgets, you get lots of widgets. You measure lines of code, semicolons all the way down. Lots of lines of code. Are they good lines of code? Who knows? I get paid by the K-lock, right? I got lots of lines of code. You measure people by ranking them against each other. A lot of companies do this. You get antisocial behavior. Like, where is the sense in me helping my peer do better so they get the raise that I wanted? How come companies can't figure this out? I don't get it. If you want social behavior, you have to measure them on how they are socially. So I have two metrics I tell managers to use. One is who's using your stuff. Are you building things that are useful to the rest of the company, right? So who's reusing your stuff? And you got to have the second one. Whose stuff are you reusing? Are you wasting all my money building wheels, or are you reusing the wheels that are already built? You need the two of them, right? So that people get together, but you measure them on being social. They're going to be social. DevOps also changes the objective. We used to think about mean time to failure. You put it on big iron, don't let it ever go down. Check, double check before you made any move. But now it's all about mean time to recovery. Yeah, I'm going to run fast, I'm going to fall, but I can get up really quick and keep running it. I will get further down the road, running, falling, and getting up, than you will tiptoeing very carefully down the road. And you may never fall, but I'm going to get there first. You want to be careful with metrics, vanity metrics, right? A lot of people, we got 10,000 hits to our website. Let's throw a pizza party. Well, what's 10,000 hits, right? Did one person nervously click 10,000 times? Did 10,000 people click once and then go away? You don't know. It's meaningless. A hit is meaningless. You've got to make sure you have actionable metrics. So you've put something out there, do some A/B testing, split it. 50% of the customers see this, 50% see the old thing, and then measure, did I get the behavior that I want? And then if I did, I could do more of the good behavior, less of the bad behavior. I want to make sure your metrics are actionable. The 4 top actionable metrics: mean lead time to getting something out the door, release frequency, how can I be responsive to change failure rate, if I'm pushing stuff out there and it's breaking, and mean time to recovery, of course, can I recover quickly? So measurement should encourage innovation and collaboration, and not punish failure. This is a DevOps maturity matrix. You could probably pause the video and look at the whole thing. But, are you, silo-based blame game finger pointing, or you have a culture of continuous improvement that permeates the organization, right? And all the shades in between of that. So the key takeaways here, right? DevOps, breaking down the silos. Culture is number one. DevOps is working differently, measuring differently, being able to recover quickly from failure, and make sure you have a blameless culture, and that every failure, seeks knowledge on how not to do it again. I like to say, this is a quote. I love this quote. If you want to build a ship, don't drum up the men to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. You hired good people. Give them the vision and get out of their way and let them do what they do. They're going to surprise you. So I like to say, we don't do DevOps. We become DevOps. Okay, so that is the DevOps piece. Hopefully you guys have your software down and installed and loaded, because we're going to move on to the next section, which is Agile Development and Planning. And so I'm going to use ZenHub. I'll show you how to get onto ZenHub, and I'm going to plan out the rest of the hour and 2.5 hours yet. Not even. We're going to plan out the rest of the evening here on the East Coast, and do it in an agile way. So the same repo that you had before, github.com/refrano/DevOps-workshop-2020. I need you to fork that repo. So that's this repo here, right, that we have here, the Refrano DevOps. I need you to hit the fork button and then fork it into your own repo. So let me just take you through that, so in case you're not familiar with it. So go to My DevOps. You probably still have it up in a window, and you want to hit the fork button on the side. and fork the code. It'll prompt you if you have multiple accounts. It'll prompt you what account to fork it to, and then you'll get the little the book with the fork in it on the copy machine. For those of you who don't know what copy machines are, you're probably looking at that and, what is that thing? It's a copy machine. When we copied physical things, not digital things. And the repo knows it's a fork. So you should get a fork with you. I already had it in my Refrano, so I actually forked it to my IBM DevOps organization. But you'll probably be going the other way from Refrano to whatever your name is in GitHub. But it'll say forked from, and then it'll definitely say Refrano/DevOps Workshop 2020. So you'll know you're done when you've got that forked. Now, forks don't have issues by default, because usually when you create a fork, you're doing social coding, you create a fork because you're going to respond to some issue that's in the main repo, but you need a copy that you can work on because you're not part of that organization. And so you can't push changes. So what you do is you use a fork to create your own copy in your own account, and then you work in your own account and fix whatever it is or add the new feature or whatever. And then you create a pull request, and you put that pull request back to the other account, and then that's the issue that you're answering. But we're not going to do that. We're just going to work solo today. So I need you to go enable issues. And the way that you do that is go to settings. So click on the settings tab and then scroll down, and then you'll see issue is unchecked by default. I want you to go check it and enable issues. And then when you come back up, you'll see there's issues. So if I go here, right? So here's my fork, right? From Refrano. I go into settings, and then I scroll down. Well, mine's already enabled, right? So there's issues, right? Oh, it allows me, actually now between now and the time I took that screenshot, it's changed. It allows you to set up templates for your issues and stuff. I go through that in my class, but I cut that out today because of time. But you want to make sure you check issues. And then when you go back up, you should see issues, so that you'll see that you click on issues and you'll see all the issues, because you won't have any issues. We're going to do that next. But you'll see the issues there. Okay, so hopefully you guys have that happening. Now, the last thing you need to do is you need to clone your repo, not my repo, your repo. So the key thing here, I should have made this in red. The key thing here, although highlighting it doesn't make it much better, is that it's github.com/your Git account. So the easiest way to do this, right? You go to Git, we'll go to code, go to the code tab, and you click on code. And then if you have SSH keys, you use SSH. If you don't have SSH keys, you could click on HTTPS. I use SSH keys. And then you just click on the little thing that copies it to your clipboard, and then you can go cut and paste, right? And what you want to do is say git clone paste, and that'll be whichever one you copy. And then that will clone it down to your workstation. So before you do that, you want to get to whatever folder you're going to put today's work in. And then git clone and clone your repo. Don't clone my repo. And that shouldn't take long. It's only a couple of K. It's not 21 KB. Then it's going to create, oh, this is wrong. I changed the name of the repo at the last minute, and I didn't change my chart. So it's going to be CD DevOps Workshop 2020. It's going to be the same name as the repo, right? It was originally DevOps Workshop from the last time, but I wanted to update a lot of stuff. So git clone, paste, CD, whatever folder it created, DevOps Workshop 2020 is what it should have created. And then the most important thing, Vagrant up. Now, remember I told you infrastructure is code. This is what your developers can do to get a common infrastructure. So before there was Vagrant, I used to create virtual machines for my dev teams. And I would actually start with an Ubuntu ISO, and I would use VMware at the time and VMware Reader, and VMware Player, I think it's called. And I would create these ISOs, and then I would upload them to an FTP site, and then they could download them and they could bring them up with VMware Player. But they were like 4 to 6 gigabytes. It was like download them. Yeah, okay, download them with the breakfast, and then by lunch maybe you had the download. Because back then networks were slow. I'm old. And so now the Vagrant file is just this. It's just a text file. It's just a little text file. That's all it is, right? Put a text file up there, and it's going to download the box, right? When it sees this Ubuntu box, it's going to download that from the Vagrant site, the Vagrant cloud. But that's all you have to do. So that's what I want you to do. Clone it, CD in and Vagrant up. I have already cloned it here, and I CD'd in, so you can see I'm in the DevOps Workshop 2020 folder, and I'm going to do Vagrant up. The difference is I already did Vagrant up once to make sure it worked, and the first time it installs everything, so it takes longer. I want you guys to hit enter right now and get yours going. I'll hit enter too. The second time, third time, every time after that, all it needs to do is bring up the virtual machine. It comes up pretty quickly, right? But I didn't want it installing all of this stuff while I was trying to present and have my fans spinning and trying to talk to you. So I tried to stage this a little bit. So please forgive me for that. But you should see something similar going on your screen. And then mine's going to end and yours is going to start with a bunch of green. I'm doing, an update and I'm installing Python and all the things that are getting installed. So have that cooking in the background while we move on to the next piece. Okay, so you're probably all familiar with the Agile Manifesto, right? Individuals and interactions over process of tools and working software of a comprehensive documentation and customer collaboration of a contract negotiation and responding to change over following a plan. The key thing is that while there's value of the items on the right, we value the items on the left forward. It doesn't mean you don't document, but I can't ship documentation. I can only ship running code. And so it's important that I make sure that I've got stuff to ship and then I can come back later and I can go document it. So I've got agile development teams. We talked about this. I just want to talk about Agile and Scrum for a moment because people use them interchangeably and then there is a slight difference. Agile is a philosophy. Scrum is just one of several methodologies. So, while you could think of Agile and Scrum as one, really Agile is a philosophy, doesn't prescribe how to do it, and then Scrum is prescriptive, right? It's a process for being Agile. So I like to say Scrum, easy to understand, difficult to master, right? There's only a few rules. And the reason I have the ballerina, it's like just dance on your toes. How hard could it be? You dance on your toes. How hard? It can't be that hard, can it? Right? And we know it's deceiving. And Scrum is like that. It's deceiving. Simple rules. When you get into it, you really need to understand, how to. It seems kind of counterintuitive at first, but it provides structures and roles and meetings and fixed length iterations. So you've got your Scrum team. You guys are probably familiar with this, right? Small team of dedicated people. You've got your product owner, your Scrum master, your developer. Those are the only roles in a Scrum team. There are no project managers in Scrum. The closest thing to a project manager is the Scrum master, but not really, because project managers assign work to people, right? Command and control, Taylorism. Scrum masters don't assign work to people. People assign work to themselves, right? They're a self-managing team. And then you've got a vision and you set off one iteration at a time to step towards that goal. So let's talk about agile planning for a moment because we're going to plan out the rest of the course here. So in plan, develop, build, test, deploy, we're in the plan stage. There's lots of tools. Jira is probably the most important. Pivotal Tracker used to be like the tool, and then they kind of fell out of favor. Jira, Lancia has done a great job of getting Jira out there, but we're going to use ZenHub because it's free and it's built into or actually works closely with GitHub. And so the only thing in ZenHub is a GitHub issue, and developers know how to work with issues. And when they close an issue in GitHub, it's closed in ZenHub, right? It's not another tool that developers have to work with. And so I like that. And so it gives you a nice Kanban board, and we're going to go off and we're going to make our Kanban board. If you want to follow along, there's two ways. Every browser will work with app.zenhub.com, and I use this when I'm using Safari because there's no plugin for Safari. There's only a plugin for Chrome and Firefox. But you can go to app.zenhub.com, and then you can sign in with GitHub. It'll ask you for your GitHub ID, and then it'll ask you what repo do you want to create a workspace for, and you want to select the DevOps-Workshop-2020 so that we can work with that. I like using the plugin. It just, for me, it has a couple of nice features that I like. So you go to www instead of app, www.zenhub.com, and then you do try for free. And then when you try for free, it'll say you want to download, I see you have Chrome or you have Firefox, only works with Chrome and Firefox. But then you do, add it to, then it'll say add ZenHub to GitHub, right? Because you need to authorize, yes, a new plugin's going to work with GitHub, yada, yada. And then once you say, yeah, authorize, then it's going to give you, okay, download the extension. because it's an extension for Chrome and Firefox. And so then you add that extension. I think I'm using Chrome here. So you add the extension for Chrome, and then you have this ZenHub in the middle, right? Until you install the extension, you don't see that ZenHub tab. After you install the extension, you see that ZenHub tab. So that's how to get that tab. But if you don't want to do the plugin, you can just go to app.zenhub.com. I have both of them here. So this is app.zenhub.com, and this is the plugin. And, you know, the reason I like the plugin, I still get to see code and issues and pull requests, whereas app.zenhub.com, you know, it's nice. It kind of, all that goes away. But then I have to go over to my repo to do stuff. Of course, you can create issues and stuff here. Don't get me wrong. But if I want to go look at the code or something, I have to go back over to another tab. So I'm going to use this one. I think I'm going to use this one today. It doesn't really matter which one I use. And it doesn't matter which one you use. Okay, so when it tells you to create a workspace, and it will, just use the same. I find it easy. Just use the same name as the Git repo. So DevOps Workshop. You can make it pretty. It doesn't have to have hyphens. It doesn't have to be lowercase. DevOps Workshop 2020. You know, and then click finish. That will create that workspace, and then you'll see a Kanban board with nothing on it because you don't have any issues yet. But we're going to go fix that. So, matter of fact, let me tell you how we're going to fix that, and then I'll come back. So, no, let me keep going because you're probably still catching up. So, what's a Kanban board? Well, it's really just, what are you going to do? What are you doing now? What did you do already? Right? It's to-dos, doing, and done. People make it really complicated. It doesn't have to be really complicated. To do, doing, done. It's very simple. Now, I realize you're managing product backlogs, sprint backlogs. It gets a little more complicated. So, you know, this is kind of what a real Kanban board looks like. Usually when you're co-located, it's a real board with stickies. But you can see on the left, product backlog. On deck is kind of current sprint. Doing is things people are working on now, and done is things that we got done. So they've kept it, even though it looks complex, they've kept it kind of simple. But I've seen people make like, you know, 10 columns is like crazy. Don't get too crazy. The default pipelines changed since I created this chart. They changed like last week or something because I just presented this to my students not too long ago. It used to just be new issues, Icebox, backlog, in-process, review, and QA. Now they have, and I was going to say the Icebox was my product backlog and the backlog was my sprint backlog. But now they actually say new issues, Icebox, product backlog, sprint backlog, in process, review, QA, done. I love it. I love it. It's perfect. So what are new issues? New issues are all the new issues that people create that you haven't looked at yet. That's your inbox. That's stuff I haven't processed. Right. And so, you know, at the end of a backlog refinement meeting, you want to get everything out of new issues and put it either in the Icebox, the product backlog, or the sprint backlog. The product backlog is all the things that I'm going to do in the future sprints. Icebox is things that are, future. Sprint backlog is current items in the current sprint, and then in process are things people are working on. And then review QA is when you make a pull request. I have it moved to review QA so people can review the pull request, and then done means I'm done. And then at the end of the sprint, you can close them all when the product owner says they're done. So sprints, you're probably familiar with this. Your 2-week sprints, they're iterations through. Right? So you have your backlog and your sprint backlog, and then you iterate through your daily stand-ups, and hopefully a valuable product comes out. So these are the 5 Scrum meetings, and then I'm going to go through and we're going to make our backlog. So yeah, backlog refinement, we're going to do this. Get all your stuff ready for a sprint plan. Sprint planning is when you actually do the plan, and then every day you do your daily stand-up where you talk about what you've done, what you're going to do today, and what you blockers you have. And then at the end of the whole sprint, you do a review. And then a retrospective on what went wrong, what went right, went wrong. And then you start the whole thing all over again. Sometimes teams call the sprint review a playback meeting or something. You'll hear those terms. How do we map these concepts to GitHub? Sprints or milestones? There are milestones. You won't see a sprint in GitHub, right? You'll see it in Jira. You won't see it in GitHub. So GitHub has milestones. A sprint's a milestone. Epics are epics. There are epics. The user stories are really issues. If you want to create tasks, you could use Markdown as a checklist. And then the product backlog is any open issue that's not in a milestone, right? Not in a sprint, it's product backlog. And then sprint backlog is all the issues that are in a milestone. So let's go off and work on this, okay? And then we will pause it. Okay, so I've got all my stuff in new issues. Now, how did I get these here? I promised you I would tell you how I got these here. So what I did was, let me open this up in another, not a new window. I wanted to say another tab. Thank you. Right click, another tab. Okay. So this is the repo that you cloned. If you go under docs, let me make this bigger for you. You guys can probably see it. And then under docs, there's stories. I took all the stories and I put them in there for you so you don't have to type them in, right? So this is what we normally do when you're typing in the new issue. So you click on a story, you click on raw, you do Control A, Control C on a Mac, Command A, Command C on a PC. No, the other way around. Control A on a PC, Command on a Mac, right? So you copy and paste this, and then you go over and say new issue, and you paste it in there, right? So now these issues use Git Markdown, and then take the first line. The first line is the title, and we'll put the title in here. And then click, when you click on previously, it gets formatted nicely. So what I need you to do now, as I'm working through this, if you want to work through it with me, is to just take those 8 issues, cut and paste them into new issues, and then click on submit new issue. I already did this, obviously. Submit new issue, submit new issue, submit new issue, and then you'll have the same issues that I do. But yeah, let's cancel. So let's go back here. Oh, stop. Confirm. Sorry. Okay. Okay. So you'll see. Oh, I've got some things in progress. Let's see what we have here. So I'm going to go over and look. Present your introduction and setup. That's done. Present the DevOps overview. I think I'm done with that. So I just drag it and drop it over. And then introduce agile planning and development. That's something I'm doing now. So I drop it in and I assign it to myself so that everybody on the team, of course, there's nobody on the team but me, but everybody on the team, still a true statement, knows that, hey, Rafrano's working on that one. Okay, good. So now let's go through and do quick backlog refinement. So what you do is you look at each one of them. Now we're going to implement these. So here's create a skeleton Flask app. I use this syntax that we use in behavior-driven development. As a some role, who's it for? I need some functionality so that I get some business benefit, right? So now I know who's it for, what is it, and how beneficial is it to them. And that helps me rank the backlog. What's important, what's not important. Maybe things for the customer, a little bit more important than things for the developer, right? Things with certain benefits, more important than things with other benefits. I like to put in assumptions. You always know something, right, about the story. And so I like to put in the assumptions. The assumptions here are only the root URL is needed, and call it app.py for now. Just a little app.py Flask skeleton. And then the acceptance criterion. For this, I use the Gherkin syntax, also part of behavior-driven development. It's this given, when, then, and syntax. So given I have a skeletal Flask app, let me make this bigger for you guys. Sorry, yeah. Given I have a skeleton Flask app, when I call a /URL, then I should silly hello from Flask return, right? Because it told me what it wants to see in return. So I'm going to take that one. We're going to do these immediately. So I'm going to drop this into the sprint backlog. We're going to make that part of a sprint. I should probably make a milestone first. So I'm going to go over here and say click and milestones, and we'll call this sprint 1 before the break. You can give it a description, put your goals here, put your start and end dates, right? So they can be tracked, and then create your milestone. There's no sense in me putting a date because we're not going to go past 2 hours. And then I can take these and start to put them in a milestone. So then, oh, there was an error creating the milestone. Okay, so let me go. Was there really? Let's go see. No milestone. Okay, so let me go do it a different way. Sometimes these don't work as you would wish. So you can come to issues. You can click on milestones from issues. You can create a new milestone at issues. This is sprint 1 before the break. And then I'm not going to put a description. I'm just going to create the milestone just to get it in there. So that one worked. We can see % complete and all that stuff. I'll go back to ZenHub, and then I'll go back and put this in the milestone. So now I'll put it in the sprint 1 milestone, and I want to size. I want to give it an estimate. I'm going to use story points. So story points are just t-shirt sizes, small, medium, large, but they're expressed as a Fibonacci sequence. I like to make 5 medium, 3 small, 8 large, 13 super large. I don't use any of the other numbers in my teams. So I'll just, actually, this is a small one. This isn't even a 5. I'm lying if I said this is a medium. I'm going to make it a 3. This is going to be so trivial. It's crazy. So add a counter where each get increments the counter. So normally I'm getting ahead of myself. These would all go into the product backlog. So let me do it this way. We'll put it in the product backlog. We might estimate it. I'm going to estimate that one as a medium because we're a little more work on that one, and then make the counter persistent. And I'm going to start. So here, we'll make it persistent. So you'll notice I have some stories down here. Now this one says introduce social coding. And in social coding, I'm going to implement story 1. So before I get to this story, I'm going to put this in the backlog, in the sprint backlog. So I'm going to introduce social coding first, and then I'm going to create the skeleton Flask app. I've got a dupe here. I cut and pasted this twice. So I want to go to my labels, and I want to say this guy's a duplicate. Where is he? There's duplicate. And then I'm just going to close the issue because it's the dupe, and then get that out of the way. That happens sometimes. People ask for the same thing twice. All right, so then introduce the team to test-driven development. So when we do that, we're going to implement story 2. So I'm going to put this one in the backlog here before this story. Then I got introduce microservices. So that's going to be stories 3 and 4. So I'm going to drop that one after story. So notice they're sorting for me, right? After story 2. Are they going in there? Introduce microservices. Good. And then, so 3 and 4. So then 4. Now notice I'm running out of room, so I can make these wider, so they're easier to work with. So 3 and 4. Then I'm going to introduce continuous integration, and that's going to be before stories 5 and 6, right? So I'm just planning out. These are the things that I need to do. Where's my 5 and 6? They're going to go afterwards. I'm trying to get around the little thing here that's sharing my screen, but it's okay. I can deal with it. And then present an introduction to Docker. So I'm going to do that next. I'm going to make this even wider, so I have to go down. So then we're going to do intro to Docker after that. Nope, intro to Docker after that. Then we're going to add Docker support. Sorry. And then I don't think that went the right place. Where did Docker support go? We'll fix it in a minute. Let me make these go back a little further. Okay. And so I'm going to make this full screen. Shift F makes it full screen, so I can see a little bit more. Then I'm going to add the Docker support. So that's as introduced to Docker. Then we're going to do Kubernetes. So now I know exactly, what I'm doing. And then add the Kubernetes support should be at the end. Okay. So now I've kind of groomed my backlog. I've gone in. What I should do is, I should go in and size. I'm not going to size these documentation ones because they're just my presentations. So make the counter persistent. So we're going to add persistence, and we'll say maybe that was, and so you do this as a team, right? Is it a big story? Is it a small story? Is it a medium story? And you can see what's happening here is you have, 12 issues with 5 story points. You kind of get this velocity of what's going on. And then you have a sprint. Once you do this, then you have your sprint planning meeting. So I'm going to continue planning this sprint, and I'm going to say we're going to do introduce social coding. Then we're going to do 1. Then we're going to this didn't sort correctly. So this has to go down towards the bottom. Sorry, guys. Introduction to Docker before Docker support, and test-driven development next. Yeah, and that's going to be 2. So then we're going to do test-driven development, and then we're going to do 2. So that's going to be the sprint. So I'm going to take these and put them in the I'm going to put them in the sprint as a milestone, right? So milestone, sprint 1. Put a milestone in here. Oh, it was already in sprint 1, and then milestone. That was in sprint 1. Sprint 1. We'll put this one in sprint 1 and then put it before the other one. But you get the idea here, right? I'm just going through and, shifting them up and down. Test-driven development is going to come before. Did these go out of order again? Add to counter. So we're going to do, we did create a skeletal Flask app. I think that's what I did. I moved the wrong one. Then we're going to do social coding, add the get, intro to test-driven development, and then did that just move or was it me? Do the get, and then TDD, and TDD was going to be, what did I say? Story 2. That was story 2. I think we're good here. Microservices, make the counter persistent. I think we're good here. Okay. All right. So now that we have somewhat of a plan, and I'm going to say that this is pretty much what we've done with Agile development planning. What we're going to do is move on to social coding with Git, and then once we do this, we're going to take a break. So just one more piece I want to cover. So this is really learning the mechanics of the Git feature branch workflow, which a lot of open source projects use. So what makes a senior developer senior is not that they know the syntax of a given language, but they have experience working on large complex projects and users' business goals, and they understand how to work as a large team. So these are my rules for becoming a Git Jedi. One, you create a repo for every new project, right? You don't have multiple projects in a repo. You want one-to-one repo to project. Number 2, you create a new branch for every new feature. We don't use long-lived branches, right? We create a new feature, a new story. We create a new branch, work on that story. And then number 3, we use pull requests to merge things back to master. We don't commit to master. We don't merge to master on our workstation and push. We use pull requests. So this is kind of the etiquette of working in a DevOps organization and any real open source organization. So Git, you're probably all familiar with Git. It's a distributed source code management system. GitHub is a place to host Git repositories. There's also Bitbucket and others. And I just want to, Git is the tool, GitHub is the website. People kind of get these confused. Just wanted to point that out. Git works with a lot of things, not just with GitHub, but we're going to use GitHub today. So this is, how many of you know Git, right? So it's this, it tracks collaborative work on projects through a beautifully distributed graph theory model. Oh, cool. How do we use it? No idea. Just memorize these shell commands, type them in to sync up. If you get errors, save your work elsewhere, delete the project, download a new copy, right? Put it all in a zip file, do something, and then, bring the zip file back. So if you're working that way, you don't know Git, right? So, as I said, it's a decentralized source code management system. And basically this is how it works. You have your workspace, and then you say git add, and that puts it in a staging area. The staging area is kind of like a laundry list, shopping list. When next time I go shopping, this is what I'm going to buy, right? The next time I commit, this is what I'm going to commit. So you add it to the staging area, then you do a commit, that puts it in your local repo. That's still on your workstation in that .git folder. Then when you do a push, it pushes it up to GitHub or Bitbucket or wherever to the remote repo. Then you can fetch to just your local repo to see what changes. It doesn't change anything in your workspace. If you want to change it in your workspace, you do a pull. A pull will do a fetch, so I almost never fetch unless I'm refreshing from an upstream. But you do a git pull, and that pulls stuff down to your workspace. If you make a mistake, you could do a git checkout. It will get the copy that you last committed from your local repo, and it will pull that back out into your workspace. And then you can do resets. You could say reset. You committed something, and I'm like, I didn't want to commit that. I want to commit more things in a commit. You could do a reset soft, and that will put stuff back in staging, so you could add more things and commit again. Or you could do a reset hard, but be careful. A reset hard will delete files that didn't exist before the commit, and that will bring the changes right back to your workspace. So the feature branch workflow, right? You create a repository, or you can fork it like you did fork mine. You clone it to your local system. You create a branch. You commit your changes. You push your changes. Create a pull request. This is what we're going to be doing, right? So it's kind of like create a branch, add commits, open a request. You could discuss the request. People might ask for changes or something. At some point, you want to build it. We're going to use Travis CI to do that, and then you merge the code back in. The real workflow is, right, you do these things and you run the test suite, and then you make changes and you run the test suite, right? And then, you want to make sure you're constantly running those tests to make sure that you didn't break anything, right? So testing is really important because you want to make sure that the pull request, isn't going to break when it runs in Travis CI. And you want to make sure that you're not breaking the build, which is why you're running these automated tests. You got to have automated tests to make sure that you don't break the build. Here's an example from my students. And you can see that was the start of a sprint. This is the graph that they give you on GitHub, and this is, time to, submit the homework, right? And so all the merges go back in around the same time because the homework is due. So what we're going to do is we'll create a new branch, get checkout B, my new feature branch, write some code. We're going to commit the feature, push it to a new branch. There will be no next day. We're doing it all today, but you could add more, do another push. And then eventually you're going to make a pull request. And before you make a pull request, you want to refresh master, right? Because other people are working, they're merging to master. Your master might be out of date. Your branch isn't going to merge anymore. So always, before you do a pull request, you do git checkout master, git pull, get the latest stuff in master, then git checkout my branch, and then merge master into my branch. And then, fix anything, add it, commit it, and then push it up to the remote branch. You want to make sure you're always in sync with master. Okay, so let's go do that. Let's do one of these stories. So I'm kind of done with this, and I want to start working on the next. I want to work on the next highest thing, right? In the sprint backlog. I only want to work on stories that are in the sprint, right? Because that's stuff that we said we're going to get done the next 2 weeks. I don't worry about the product backlog. And as a matter of fact, I can go filter by milestones and everything goes away, but that sprint, right? So that's why it's important to keep all things in a sprint so the filters work. And I see this one wasn't in the sprint, right? That's why it disappeared. So let's go down and put it in the milestone. I made a mistake here. Boom. Okay. Okay, so create a skeleton Flask service. So I'm going to open it up and I'm going to assign it to myself and I'm going to read it. Now, it should, if you had a good grooming session, it should have everything the developer needs to know. They shouldn't have to start asking questions when they pick up a story. If they start asking questions when they pick up a story, you got to do better grooming. These stories have to be sprint ready. They've got to be ready for any developer to pick them up and start working on them. So it says, okay, as a service provider, I need a minimal Flask service so that my developers can start adding code to it. All I need is the root URL. So that's an assumption. I don't have to ask people, how big does it have to be? What's got to be in it? It's a groom story. Only need the root URL. Call it app.py for now. Good enough to go. Just get something out there. And then given I have this app, when I call the root URL, it should say hello from Flask. Okay, so we've got this. And I've assigned it to myself. So you can do the same. Assign it to yourself. And then we're going to go back over. Now notice I did the vagrant up. So when you're done doing the vagrant up, you then want to do a vagrant SSH. So let me clear my screen here. So you want to say vagrant SSH. That's how you get into the virtual machine, right? So vagrant SSH takes me into the virtual machine, just like I was SSHing into, a machine in the cloud. So here I am, I'm inside the virtual machine. If I do pwd, I'm in the home vagrant folder. So the user in a vagrant VM is always vagrant, unless you change it. You can change it. But then something magical happens. One of the things it does is it shares the current folder inside the VM. And it shares it at a point called /vagrant. So if I look at root file system, I see that there is this vagrant folder and it's owned by me. It's owned by vagrant. So I'm like, okay. So let me do cd/vagrant. And when I do ls-l, boy, those files look familiar. There's my lessons, my service, my tests, right? This is the code that was on my workstation before I said vagrant up. So check this out. I am going to be editing code on my workstation from inside the VM. So I have the right Python environment. I've got, if I do a Docker, we're going to learn about Docker, but I'll show you if I do a Docker PS, I've got a Redis Alpine Docker container that is running. It's listening on port 6379 so that I could use Redis when I add persistence. I've got my whole environment just by saying vagrant up. I got my whole development environment the same as everybody else's development environment in my organization. And The code is not copied into it. So that what happens if it blows up? No, the code stays on my laptop. That means I can use an editor on my laptop. This is the code, right here. You know, this I'm using Visual Studio Code. And actually what I'm going to do is, you see, we print my working directory. I'm in users Refrano GitHub demo. I cloned it to this demo folder, DevOps Workstation 2020. And so from in here, so I said code dot when I was outside in there, and that's what brought Visual Studio Code. In here, I'm going to do the same thing, Vagrant SSH. Now, there's a plugin for Visual Studio Code that will allow you to work inside the virtual machine. It was a little too much, I thought, to set up for today, but it's a really cool plugin because you can do it on remote servers in the cloud. So now you see I'm in the same place. I'm in the same place. If I do cd/vagrant, I'm in the same place. These are the files that are over here. And actually, I'm going to remove this silly log file that Vagrant creates because I hate it. So now the log file's gone. And I'm working inside the virtual machine, but I'm editing on my laptop using my favorite editor. So let's go do what we need to do. So I'm going to right click here and say new file, and I'm going to call it app.py. And then I realize I'm on the master branch. I forgot to make a feature branch. No worries. So let me do this out here just because it's bigger and you guys can see. All right. So I'm going to say git branch and see what's out there. Hopefully there's nothing but the master branch out there. So git branch will show me my local branches. Git branch -a will show me my remote branches. So I just have master on local and the remote masters. So I'm going to say git branch B. Oh, I'm sorry. I'm going to do it in one fell swoop. Git checkout -B for create a branch. And let's call it Flask skeleton, but with a K. I create a branch called Flask skeleton. It tells me, hey, you already have a modified file there, right? Now, I happen to modify that file before and not check it in, so my bad. Let me do a git checkout period. So git status. Status says I've modified a file. I'm going to do git checkout period, and then git status. And now that modified file is gone. I checked out the version, right? I threw away my modification. I checked out the version that was already in my local version control, but I still have my app.py that's sitting out there. Okay. So now I've got app.py and I'm on that branch. And if you notice, it's switched inside of Visual Studio down in the corner, probably down in your corner, Flask skeleton. So I'm on this Flask skeleton branch. So let's create this skeleton. So I'm going to say from, if you're not familiar with Python or Flask, you could just type along with me. But I will tell you, you can cheat. So see where it has lessons here? Under the lessons, all the code is in the lessons. So at any point in time, you can cut and paste and get started. But this is pretty simple. So let's just do this. So from Flask, import Flask. So that imports, if I could spell import correctly. Let me see if I can make this bigger. Too big. Way too big. Okay. All right. So import with 1P. So from Flask, import Flask. Then I'm going to create a Flask app equals Flask underscore name underscore to give it the name of the module, just because that's how you instantiate Flask. And then I'm going to create that first route, that /route. We use that with a decorator, app.route. I don't expect you guys to know this, but I'm just walking you through it. So I say create a route. The route is just /, right? It's the default route. And then this is a decorator. It decorates a method. So I'm going to create a function right under it. So def, and I'm going to call this get index. Well, you can just call it index, right? Usually it's index HTML, right? Def index. So that's going to be my function. And then it's going to return. What did they tell me to return? They told me to return, I think it was hello from Flask, right? You want to make sure you do it right, because that's what this is the criteria. Hello from Flask, right? So that's my criteria. Whoops. Return hello from Flask. Okay. So, whoops. And I save. So that's it. That is my app. I'm going to come down here. I'm going to clear my screen for you. So now I'm going to say Flask run. Now, if I normally say Flask run, you'll notice it's listening on 127.0.0.1:5000, right? So it's listening on localhost 5000. The problem with this is the local host is the VM. It's not my local host, right? It's the VM's local host. And so I won't be able to get to it from outside the VM if it's only listening on localhost. So what I need to do instead is to tell it to bind to all of the ports. So that would be Flask run -H for host and then 0.0.0.0. And just tell bind to all the ports. And I'll give it the 5000 just to, but I think it defaults to 5000 anyway. I have to spell Flask correctly, otherwise it's not going to work. Flask run, it's going to bind right to all the ports, and I think that's all we need there. And so now, no address associated with hostname. Why didn't? Oh! I don't think I'm allowed to put the 5000 on there. I think there's a port. There's a -- port thing. We're going to use GUnicorn later, and that syntax works in GUnicorn, so sometimes I get confused. But now it's binding to all the adapters, right? So now I should be able to go to localhost 5000. Now, why should I be able to go to localhost 5000? Because in my Vagrant file, I thought ahead. I said, please forward 5000 on the guest, the VM, to the host, my Mac, right? So it's going to forward 5000 from the VM to my Mac. If I didn't have this here, then I would have to go to 192.168.33.10:5000. That would have also worked. Okay, so you can forward the port for convenience, or you not forward the port. But the critical thing is that you listen to 000. And this is going to be true in Docker containers as well. That's why it's kind of important. So now let's go to, let's get a web browser up and see what we can do here. So I'm going to say localhost 5000. Hello from Flask. It works. Yours should work as well. Just go to localhost 5000, and we have hello from Flask. Okay. And so now I've got that. It seems to work. And so I'm going to hit Control-C, even on a Mac, Control-C on a PC, Control-C on a Mac, to get out of that. And now I'm ready to check in my changes, right? So if I say git status, and let me do this out here because I think I'm a little bit bigger out here. We can make this bigger. Git status. So now it says that app.py is not tracked. So I'm going to say git add app.py, and that's going to track it. Now if I say git status, app.py is tracked. You notice that I'm on the Flask skeleton branch. Okay, so now I want to commit that, git commit. And I want to give it a commit message, and I'll just say added skeleton. So now it's been committed. It's in my local Git, but it's not up on GitHub yet. So now I say git push, and it's going to fail because I need to track the upstream. But the reason I do this is just to show you when you forget, I forget all the time, you could just say git push and it goes, didn't you mean git push set upstream origin Flask skeleton? Like, yeah, oh yeah, that's what I meant to say. And so you could actually do a -U instead of all that -- upstream. But as long as they were verbose enough to say it here, I'm good to go. Now we push it. The first time we push it, it wants to know, going to talk to that Git server. And so now there's a new branch, right, called Flask skeleton. And if I go up to my Git, so here's my DevOps Git. We're going to go refresh this. Hopefully it's going to tell me, hey, this only happens for a little while, and then it goes away. Very recently, like less than a minute ago, somebody did a push. You might want to do compare and pull request. Now I can go to pull request, create pull request, but I got it here, so why not? So I'm going to do compare and pull request. It says I'm able to merge, so it's going to merge. Now you got to watch this because it's a fork. It wants to merge back to Refrano. Do not send your merges to me. I don't want them. Okay. So what you got to tell it is, no. I want this to go to my own, right? My master, compare flash skeleton. I don't want to go, but if you were working in an open source project and you were just going to go make a pull request of that project, that's kind of the default behavior, right? Like, why would you fork, a repo unless you're going to go contribute back to the original repo? And so that is the default behavior. Just watch that. And so now it's saying, oh, we're going to open a pull request. It is going to compare flash skeleton to master. It says it's able to merge because nobody else has done anything in master. And then you want to say, what did I do? Added an app.py to listen on root URL. Whatever, right? You just put somebody else is going to review this. Give them a break. Tell them what you did. Although they can look at what you did. I'm going to show you in a minute. So now I've got this pull request. And so I'm going to hit create pull request. And now it's checking to see if it can merge. So now when somebody comes in, we come to pull requests, right? So someone comes in, hey, I need to have my pull request reviewed. They click on add skeleton. And the first thing you do is click on files changed. All right, what did this person change? Oh, and it gives you a nice diff, right? Every pull request is an opportunity for a code review. We don't do big code reviews anymore. We review every single pull request multiple times a day, maybe. And we're just reviewing these little changes. I made some little changes, very easy to review. So I review it, I look at it, I say, yeah, that looks pretty good. I might want to make some, comment on some changes, approve it, request it, I can approve it. I could request changes. I could do, so it's telling me owner can't approve their own pull request. Like, yeah, I should know better. But if there was 2 people in my repo and it wasn't me, you could approve it. And so you could look at what the commits were, how many commits they did. It's all there. Add good commit messages. Don't just make them blank. Don't just make them blah, blah, blah. Add good, because you never know when you want to know what was in every commit. So add good commit messages. And then finally you say, yeah, this is good. I'm going to go back to the conversation and I merge this pull request and it goes, are you sure? I confirm the merge. Then the next thing is, do you want to delete the branch? And the answer is always yes. There's no need for this branch anymore. They're short-lived branches, right? No need for it. So I say, yes, delete the branch. And so now that branch is deleted. The merge has been done. I go back to pull requests. There are no pull requests anymore. Everybody's good. I go back to the code, and there should be an app.py sitting in there, right? And there's the app.py. Everything's good. So now what does the engineer do who just created this pull request? I'm glad you asked. So now I have to do something to get back to master, because now I'm going to work on the next feature. But if I do a git status, I notice that I'm on this flash skeleton branch. So the first thing I want to do is a git checkout master. So watch ls app.py. Here's app.py. Git checkout master. I'm going to go back to the master branch. So now I switch to branch master. My branch is up to date with origin master. Really? How could it be up to date with origin master? I just committed to origin master. Your laptop doesn't go back to GitHub and check anything. So be very careful of this message. It's lying to you, right? It's lying to you. Because if I do ls app.py, there isn't any app.py, right? App.py is up on GitHub. So after I do git checkout master, I have to do git pull. Give me the latest stuff that's in master so that I'm really up to date with master. And ooh, look, it did a fast forward. App.py, 7 lines got added. Now I look at app.py and it's there. Okay. So now the changes that I made in my branch, I don't merge into master. The changes I made in my branch, I push to GitHub. They get approved. They get merged on master, and then they get pulled back down onto my workstation. So now what do I do with my branch? Well, I want to delete it. So I'll say git branch, because I never remember the name of my branches. Git branch says I have a master. So notice master has a star next to it. It's also green, but it has a star in case you're not using highlighting, colored highlighting. So I copy that, and now I say, git branch delete -d. That's going to delete that branch. Branch is deleted. Now, it also got deleted up on GitHub because I deleted it. So if I do a git branch -a, I shouldn't see it. But unfortunately, I do. It's still there. Again, my laptop doesn't know what's going on with Git until I refresh it manually. So I want to go get the latest. So I say git remote. I want to prune, and I want to prune origin, right? Origin is my Git repo. Git remote prune origin. So now it's pruned origin. So now if I do git branch A, there's no more A in there. And if you say, what's origin? If I say git remote view, say git instead of get, git remote view, you'll see I have a pointer to something called origin, which is my IBM DevOps workshop. You won't have this upstream. I created it because I made changes to the upstream and I needed them rather than cloning, forking it again. And so I define, but this is how you keep your branch up to date with the upstream, right? You want to get the latest, you define upstream, and then you have it pointed to upstream. So that points to Refranos, that points to my other one. And so then I can push the upstream, I can pull from upstream, right? I can push the upstream, I can pull from origin. So these names are like the defaults. You could have called it foo, you could have called it bar, you could have called it anything, but traditionally we call it origin and upstream, or origin is always your repo, upstream is always the thing you forked it from. Okay, so now I'm good. So if I do a git status, I can believe that status, right? I'm on branch master, I'm up to date with master, and I am ready to like work on my next story. Okay. All right, so I'm going to stop. So this is test-driven development. So we're gonna stop here, and maybe take a 15-minute break. So is the moderator on?
Hello.
Yeah. So can we do a? So a 15-minute break, which.
Okay. 15 minutes break, and we can invite your audience to supply the questions.
Yeah, it'd be a great time to answer questions.
Right, and so I already sent a message to Q&A, and I expect during the break they can submit the questions, and
Yep.
we'll to collect. All right. So
Okay.
15 minutes. So I'll let you break. I will sit here. I will guard the stage.
Okay. Great. Thank you.
Hi, John, we're back.
Okay, so we're going to kick off the second half here with test-driven development, right? If it's worth developing, it's worth testing.
We have one. I think we have one question from the audience.
There was a sorry.
I don't know if you cannot see it. I cannot.
There was a git branch question.
Yeah, the branch question, yes.
Yeah, so my only question is, did you really delete it up on the host? Maybe you didn't, and you can still delete the remote branch from from your workstation if you need to. So if you forgot to do delete branch after you merge the pull request, that would be why it's still on the host after you prune. And then you can just delete it and then push that change. But that's a little beyond the tutorial, but you can still fix it. Okay. So testing is critically important, right, to setting up these DevOps pipelines. So I want to just go over test-driven development. So this was an email from one of my students from fall 2019. Hi, Professor Refrano. I wanted to thank you for driving home the benefits of using TDD. Having worked in startups, we would always say that we don't have time to write test cases, only to see bugs post-release, waste hours debugging away on Postman. working on my capstone project, I had to create a set of API routines to be consumed by our mobile app, and I wrote test cases for every routine. It saved me a lot of time by quickly identifying errors in my SQL queries and made me more confident in the work I did. Thanks for teaching us about it. This is one of the things where, yeah, nobody's got time for testing. And then once you realize how much time it saves you overall, it's like, wow, that was a silly way of thinking. So the goal here, right, is to put together these pipelines, do your unit testing, do your integration testing, so that you can be sure that the code that you're shipping is as bug-free as possible. So, if it's worth building, it's worth testing. If it ain't worth testing, then why are you building it, right? Developers don't test. They know the code works. But they don't know that, in the future, something's going to break it, right? An operating system change or whatever, right? They claim they don't write broken code, but, future libraries could break your code. And if you have no time, testing absolutely buys you time in the end. The upfront time you spend is well worth it with time debugging, right? Because code is found everywhere, right? You need to be, you might be writing some open source library that somebody uses, in a car or something, right? I mean, you don't know where your code's going to pop up, and you want to make sure that it's well tested. So we're just talking about integration testing with TDD at this point. I'm sorry, unit testing, which is at the bottom. But then there's integration testing where we do behavior-driven development, and then of course system and acceptance tests for customers. But we're on like the left side of this graph, right? Develop, test, build, iterate through, do unit testing. So B2D and TDD, behavior-driven development, test-driven development. Behavior describes the behavior of the system from the outside in, and testing tests that it's doing the right thing from the inside out. So there's this red-green refractor workflow where you write a test case, watch it fail, and then you write some code to make it pass, and then you refactor it to make the code better. So it's a continuous cycle between TDD and BDD, right? You're outside in, inside out. You're working back and forth all the time. So BDD is building the right thing, getting the right behavior. TDD is building the thing right, making sure that it behaves correctly. So here's a test case study, right? Think about this. This is just calculate the circle, the area of a circle. And pi r squared, for those of you who don't remember, pretty simple, right? So I import from math, I import pi, I define a function, area of a circle, and I return pi times the radius squared. What could be simpler, right? Done. Push to production. We're done. Then I start writing some test cases. So I got an array of radii, 2, 0, -3, true, a Boolean, a string. People can throw all sorts of stuff at your function. And then I create a little message, area circle with radius is area. And then I say for I in radii, r in radii, I print the message, radius equals r, and area is my function call, area of a circle. And the first time it runs, I get the area circle of 2 is 12.5, blah, blah, blah. And I get the radius of 0, 0. So far, so good. And then the radius of -3 is 28.7. I mean, that can't be right. Radius of true winds up being pi. And of course, the radius of a string just like throws an exception. Code blows up, right? So code that hasn't been tested shouldn't be trusted to work. So this is how you really do area of a circle in production. You get an attribute, you say, well, if the type of R is, if it's not an int or a float, then, throw a type error. It must be a number. If the radius is less than 0 and that's not valid, throw a value error. Radius can't be negative, right? And then now it's an int or a float, it's a positive int or a float. I can calculate the radius, and then I return pi times the radius squared. So it's really, really important to do this. So test-driven development, you write test code for the code you wish you had. So you write the test first. It's kind of weird. Of course, you can write them afterwards, but test-driven development, I write a test case for the code I wish I had. So it's important. If you don't put tests in your automated pipeline, all you're doing is pushing bugs to production faster. So you got to have automated testing in order to set up these pipelines. Kent Beck says, I'm not a great programmer, just a good programmer with great habits. Right? I like that, Crow. So get in the habit of testing. Make sure they're fast, they're isolatable, data makes sense. It's one step towards a goal. So again, red, green refactor, write a test, watch it fail, and then watch it pass. There's a bunch of test suites. PyUnit is the one we're going to use. There's PyTest and DocTest. We're going to use Nose. So here's an example of a test case, right? So everybody knows what a stack is, right? Last in, first out, push something on it, and then, pop something off it. So here's the test case for a stack, right? I import unit tests. I import the thing I want to test, which is my new stack class. And then I derive from unit test my test case, and then I set it up, right? So I set up these will be run before every test case and after every test case. So I set it up by creating the stack. I tear it down by setting the stack to null. And that gets executed before each and every test case. So I don't have to put that repeatable code in every test case. I put it up there once. And then, I push 9 and I assert that if I peek at the top of the stack, I'm going to see 9. And then the second one, I test a pop. So I push 9 and then I do a pop. I make sure the pop's equal to 9. And of course, since I only push 9, I assert that the stack is now empty. I pushed one thing, I popped it, and then the stack should be empty. So that's just writing the test cases. And then this main, I don't even put the mains in anymore because now I run nose test, so I don't have to run them separately. So how do you know what state you're in before you run it? That's these fixtures, right? They're called fixtures. And so you could do a setup and a tear down a module that runs before the whole module. You could do set up a class and tear down a class. That's good for doing connections to databases. You just connect once and then run all your tests. And then you've got setup and tear down, which run before and after each test. I wouldn't connect and tear down a database connection before and after each test unless it's some kind of database that connects very, very quickly. Redis happens to be one of those. You can connect very quickly, disconnect quickly. But if they're expensive, you put them in the class method. So you might have something that's set up like, initialize the database, drop all the tables and recreate them. So you got a fresh schema and then go get a test client. And then after every one, remove all the data that you put in there and drop all the tables again. And then your test assertions are just asserting something's true, right? So sum is add, 2, 3, and I assert the sum should be 5, right? There's a bunch of assertions for PyUnit. These are just syntactic sugar on top of assert. I can assert equal, not equal, something's in a set, it's not in a set, it's true, it's false. But under the covers, it's just doing regular assertion. So here are the test cases for that area of a circle, right? So in this one, you would have test the area. So now we use almost equal for floats, and it goes to an order of fuzziness that you can rely on. So we test that the area circle 1 is pi, and that 0 gives us back 0, and 2.1 gives us back whatever 2.1 pi times that radius squared is. Then we test values, so we want to make sure that the errors are being thrown. So I assert that calling error of a circle with a -3 will raise a value error. And I further assert when I test my types that passing in true, a Boolean, will give a type error, and passing in a string will give a type error. So this is how I can check my error conditions, my happy paths, and my sad paths. You can run the test cases with Python module unit test, but I use nose tests for do those, and that gives you a nice clean look for all your tests. If you have a Windows file system, nose test won't execute anything that has an execute bit set, so be careful. You might have to use --exe on Windows. And then there's a bunch of command options that you put on there. But I put all those options in the setup.config, which you'll see in the code, so you don't have to worry about this. And then I like to add test coverage so I know how many lines of code got covered. So now, how do I know when I'm done writing test cases? So you see I got coverage here, and I got 94% coverage, right? So there's 81 statements, 5 of them got missed, and it lists the 5 statements that were missed. So we take a look at, 62 and 66. I could see, oh, my error handler. These are my error handlers. I didn't write enough test cases that made my error handlers fire. And so I might want to write a test case that gives me a 405 and that gives me a 500 so that those lines of code will get tested. So here's a test case for a 405. 405 is method not allowed. It's just an illegal call, right? So, you can't do a put. Let's say pets is your resource and you're doing a put on pets. You can only do a post to pets. You do a put, you got to do pet/some ID. So if you leave the ID off, then it's going to think you're trying to do a put on the one that you're going to do post. That'll give me a method not allowed. And then I assert that the response code is going to be a 405. So I just make a call that will cause a 405 and I test it. So there's no endpoint to put on pets. And I happen to know that, then I'm going to get a 405 back. So then you can run your coverage, and the coverage will, again, tell me now I got 95% coverage. I've increased my coverage. I can go back and look at 66. Okay, so let's go. What I want to do, I've already, during the break, I kind of looked. So we've done this skeletal service. There is a way. I didn't see it, which is kind of odd. I got to go back and look why I didn't see it. There is a way to attach the pull request to the story. And I didn't see the button when I was doing it, but what'll happen is when I do that, it will automatically move my story into review QA. right? When I make the pull request, so people know to review it. And then when the pull request gets merged, it automatically moves it into closed, not done, but closed. So I'm just going to move this over to done now. We've introduced test-driven development, so I've already done that. So we'll throw that over. So now I've got two stories here. Get a counter where each gets the counter, and then make the counter persistent. I'm in the interest of time, I'm going to do both of those stories, although you're not supposed to do two stories at once. And I'm going to do it through cheating by cutting and pasting. So let me go assign that to myself. And I know there's a lot of stuff here that we got to go do. So one of the things I want to do is, now that I'm writing more code, I don't want to have this app.py just sitting out there. And so you'll notice I already have in my code, I've got a package called service. Well, actually, it's just a folder right now called service. It's not yet a package. And I've got this app.py. And what I really want to do is move that into service. But if I move it, Git is going to think I deleted it and recreated it, and it's going to lose all the history. So here's a little trick to fix that. Instead of just saying move app.py into service, right? I'm going to put Git in front of it. I'm going to say git move app.py into service. And now when I do a git status, it says, oh, you renamed app.py to service app.py. And actually, I wanted to change the name in service. I wanted to call it routes.py. So I'll do that again. I'll do a git move service app.py to service routes.py, because I like to put all my routes in a module called routes. Just kind of, convention. So now I've renamed it, and Git should still know, oh, okay, well, app.py went to routes.py. So remember I said we're going to make this a package. So I'm going to create an underscore init underscore py, right, which will make this thing a package. And then I'm going to move the import Flask and the creating the Flask app. I'm going to move that into this init. And then I'm going to take it out of the, I already took it out of the route. And now it's, and from the routes, I'm going to say from service import app. So that's how we kind of make, we break this up into an initialization of the package, and then all of the routes. Now, since we're running out of time, I'm going to cheat, and you're going to cheat. We're both going to cheat. We're not going to tell anybody we're cheating. That's the deal. So what I want to do is go to add persistence, and I'm going to take that init.py and copy it, right? And then put it into this init.py, although it only has one other line of code. So what it's doing now is, that was the next thing to do, is to say, now I want to say from service import route. So I want to input all my routes. So now this package knows all about the routes. And then I'm going to go to my routes, and I'm going to copy that, right? Command A on a Mac, Control A on a PC, and then Command C or Control C to copy. And then I'm going to go back to my routes, and I'm just going to do Command A and Command V to paste. So what I've done is I have added persistence. So I've added a counter in addition to the little hello Flask, right? I didn't do from Flask here when I did my example. I've added a counter endpoint, and now I'm using Redis to do that counter. So initially I did it without Redis, and then I added Redis. And so I'm just skipping to the added Redis part. So I've taken getting the database out of the environment, and then I'm instantiating a connection to Redis. Now, normally you would do this in kind of an init method or something, but I'm instantiating Redis, calling it counter, and then Redis has this neat feature. You can do gets and sets on name value pairs, and one of the cool things it has is increment. So if your value is an integer, you could just say increment, and then it will just +1 the thing all day long. So that's kind of cool, and that will implement our hit counter. And so the counter is just going to increment the counter. And then I had this reset counter in here because we're going to go look at the test cases, because that's part of this. And what I was noticing on with the test cases was I would increment the counter. I'd run the next test case, right? And say, get me a counter, increment it, and make sure it's 1. Increment it again, make sure it's 2. And it was coming out 3, 4. And I'm like, what's going on? I'm like, oh, I didn't reset the counter before every test case. Now, resetting the counter could be a dangerous thing to do in production. So I said, if the app is in testing mode, and only if it's in testing mode, then this method can be called. Now, there's no way to call this method from the outside. I didn't put a route on it, but internal method, but that extra checking of if app.testing, then you can reset the counter. So that's the code that I changed. I'm going to save that. Now let's go look at the test cases. So again, I'm under 3, add persistence, look at the test cases, Control A, Control C to copy. And then I'm going to go down to test cases here. Now my test cases here was just an empty test case. I'm sorry, was an empty test case that said assert true is true. And so if you come down here and you run nose tests, oh, it might fail because I changed half the code. Nose test with an S. Oh, it still is. So test something is working correctly, right? So true is in fact true. But what I want to do is I want to Control A, Control V to paste all those test cases. And now I want to run nose tests. Let me clear this. I run nose tests, and now it tests get counter, make sure that get increments the counter, and test the index call, and I've got 100% coverage. So how did I do that? I just want to take you through this briefly. So what I did was up here, I set a variable on app. So it has a debug variable and a testing variable. I set testing to true. So testing says we're in test mode. And then in the setup, I call reset counter. So where'd that come from? I said from service routes, import app and import reset counter. So I imported that reset counter function. And then I call reset counter before each and every test. So setup says reset the counter, run the test, reset the counter, run the test, reset the counter, run the test. That's how I know I have a stable environment for every test. And then Flask has something called a test client, which is really cool because I don't have to have a server running. All right, I can get a test client, and when I run get, put, post, delete, it will make the service think that it was coming in from the web, and then it will execute get, post, put, delete on the web. So that's a pretty cool test client that comes with Flask, and so that's what I'm using. So I'm saying, and I'm storing it because this is a class, right? So I'm storing it in a variable called app. I could have called client. Client might have been a better name for that because app gets confusing because you have the app. But I got in the habit of calling it app for so many years. But it's just a variable I made up. That's all it was, as long as you're consistent. And then I say, self.app get / and then assert that the status code is equal to a 200. For get counter, I say call / counter, and then I assert that the status code is a 200. And then I say, hey, go get me the JSON out of the response that as a dictionary. And then I assert that the counter that's in that dictionary is equal to 0. So if I was to do if I was to run this and do a get on it, I would get back a dictionary with the counter 0. So let's run this. So now we can't just say Flask run because Flask will look for an app.py or a wsgi.py, but that's all it looks for. So now I've pushed that into that routes. So what I have to do is I have to export a variable called, so export all capital letters Flask _app equals, and then I have to tell it that the Flask app is in the service module. So I say service : app. Now it knows that the thing that says app equals Flask is in the service module, and the name of the variable is app. If I called it foo equals app, then I would say service : foo, right? And if I call the service module something else, hit counter, and foo would be hit counter : foo, whatever. It's just matching the names. But now I can say Flask run -h0000, and now it should run my Flask app. And if I do a get, so let's go localhost 5000. I'm still getting my hello from Flask, and then I go counter, get back counter 1, and I refresh it, and I should get back counter 2, counter 3, counter 4, right? You should get the same thing. So that's what it's getting and looking for there, okay? So this is, so when I actually wrote this, and I wanted to take you through writing it, but this could be an all-day class doing that. But what I actually did was I actually wrote this test case first. I knew it was going to be a get on counter, and I expect to get a 200. And I didn't write these yet. I just wrote these two. Get on counter 200, run the test case, fail. Okay. Go back to routes.py and add a counter, right? And so then I added that code, ran it again, then it passed. Right. Then I said, what other test cases can I write? Oh, I could look and make sure that the count was the count that I thought it was. Right. And so then I added the test case to say, by the way, get me the data and make sure the counter is 1. And then here's another one where I say, well, now let's increment the counter. Right. So same code, right? Same code here. But then I increment it 3 times. So I do a get and a third get. Right. So I do 3 gets. And then I do a final. I do a 3 gets. So I had 1, 2, 3, 4, and then I assert that the response status code is still 200, and then I go get the JSON, and the counter should be 4, and that's what I get. So that's as simple as it is to write test cases. Okay, let's go through. Yeah, that's all. So red, green, refactor, and you guys are good to go. There's a good book on test-driven development with Python from O'Reilly. All right, so cloud native apps, microservices, and REST APIs. So I'm going to go through this rather quickly because I want to get to the code example and then just do a Docker and a Kubernetes quick. So again, 3 pillars: perfect storm, microservices, thinking different about application design, cloud native, right? So, well, let me go through this one. So you guys probably know with it, the older folks like me know what a mixtape is, but how many of you from the younger crowd, who didn't see Guardians of the Galaxy know what a mixtape is, right? So a mixtape is a monolith, right? I take all my songs I like, I put them on a tape, right? And I listen to them. And then if like the 4th song on the tape, I'm kind of sick of listening to, I want to change it, I don't get to pull that 4th song off the tape. This is an MP3 player. I have to make a whole new mixtape without the 4th song on it, right? This is a monolith, right? Everything's got to change, and we do the same thing with our code, right? So we've got this application, evolution of designs here of going from these monoliths to these microservices. And so they have a different architecture. There's different practices, and there's different technology, right? Using Kubernetes and whatnot. So cloud native apps, they're all talking about, you're taking a monolith app and you're breaking it up into microservices, right? So here you got a driver management, payments, billings, kind of an Uber-like service, right? And they all talk to each other through REST APIs. Nobody's reaching into each other's database, querying each other's tables, or updating each other's tables. They're all calling each other's REST APIs. And so, Martin Fowler and James Lewis kind of coined this term microservices. Suite of small services running in their own process, built around business capabilities that are independently deployable. So instead of having a video sharing system that's a monolith with all the things scooped together, you say, I got an upload service and a streaming service and a transcode service and a download service, right? And if the transcode service is broken, well, I can still stream, I can still download, I can still upload, right? Whereas in the monolith, if something blows up, the whole thing blows up. And so now I can take them and I can scale them out horizontally. So I could have more of one service than another, and they're all talking to their own databases. So they're, loosely coupled, independent life cycles designed for resilience. And you develop them by, a single team independently, and they own the whole thing. So it sounds like a paradise, right? But, there be dragons there, right? This is my favorite tweet. We replaced our monolith with microservices so that every outage could be more like a murder mystery. Was the load balancer in the library with a kitchen knife? So there's challenges, right? You've got all this network latency to worry about now. You got all these interfaces to worry about now. It's hard to decouple transactional systems. You got to find the other services. Lots and lots of challenges. So knowing when to use technology is important as knowing how to use it. So I think you get the idea. Monolith. Everything is grouped together, tightly coupled. Everything gets deployed together. Then you split it out into microservices, and now each service runs independently. Maybe it's got its own load balancer in front of it, its own database, and then you can deploy these things separately. And this allows you to scale out rather than scale up, right? So rather than scaling up and making it better, doing vertical scaling, you can now scale out with more services and use horizontal scaling, and the cloud is, infinitely scalable. So you want these to have high cohesion, right? They have a bounded context, they go together. Low coupling, they don't know too much about each other, and low time to comprehension, right? It's kind of not a lot of code that a developer has to understand to figure out what this function does. And so again, just like the clash in DevOps, instead of building, a single big thing, it's a suite of small things. And instead of the entire application scale, you're scaling, much smaller pieces. So a good microservice, right? Things that go together. Usually a bounded context, like a business domain, is a great way of building microservices. So this is the single responsibility principle, right, from Robert Martin. So gather those things together that change for the same reason, separate those things who change for different reasons. So we usually use domain-driven design when we're trying to find microservices. We find the business context, and we build the services around those business contexts. And just here's an example. Or each one of these contexts has something called an item, but in a catalog, it means a sellable product. And in the cart, it means something that somebody's going to buy. And in fulfillment, it's something that's in the warehouse, right? So we talked about Conway's law. I have to go over that. And then you want to design for failure, right? So this is a picture of the cloud from the glossy brochure. It looks like a great place to host your apps. And then you find out the cloud's in a continuous state of partial failure. Actually, distributed systems are in a continuous state of partial failure. It's not unique to the cloud, right? But when you have distributed systems, something's always going up, going down. But if the customer never notices, does it matter, right? So if you can have enough instances out there where half of them go down and nobody noticed, not a big thing. So you want to design them to be resistant. You want to use retry patterns. If you call a backend service, it doesn't answer, call it again. Don't call it again every second, exponentially back off. Call it a second, 2 seconds, 4 seconds, wait 8 seconds, right? Retry. Here are some retry patterns in Python. I'm going quickly because I know the time is lacking, but circuit breaker patterns, right? So you call something and it reaches some failure threshold where the circuit breaker opens and then it doesn't accept requests anymore. Or maybe it sends back a canned request, and then it gives the backend service time to recover. And then it tests. It goes half open and says, let me call it once. Did I get an error? Oh, I did. All right, we'll close again. And I call it once. I don't get an error. Then I close the circuit again. There's a circuit breaker library in Python you could use to do circuit breaker. Bulkhead patterns where, you have multiple connection pools. You don't put all your eggs in one basket, as they say, so that if one pool goes bad, the whole app doesn't go down. Canary testing, where you take a new version and you only shape like 20% of the traffic to it and see how it behaves, right? Instead of giving it all the traffic. So you can test the canary, see if it's working okay, and then traffic shape the rest of it. A/B testing, 2 different versions of the application. You kind of do the same thing with traffic shaping, or even use feature flags where you can turn features on and off through configuration parameter changes. I'm going to quickly go through 12-factor. Really fast because it's important, right? So one code base, one repo, right? You don't want to have multiple code bases in a repo. You want to package all your dependencies together. Don't assume that anything's on a box. That's why we use our requirements TXT file or package JSON file to package everything up. Everything I need has to come with me. This is why Docker containers are so great, because all dependencies are in the container. Config comes out of the environment. Don't have little config files all over. You get the config out of the environment, and every cloud allows you to inject environment variables. Don't get attached to your backend services. There's going to be a database out there. It's going to be a different one in test, a different one in prod, a different one in staging. You just look for a database URL. That's why I had that database URL for Redis. And then that's the one that I use. And I don't have anything hard coded in my app. Build, release, run just says that I don't tweak things in the runtime. If I have to change them, I reconfigure the build and I run and release the code again. Single process per container. This was Heroku originally came up with these, and so it was a Heroku process, and then later a Cloud Foundry container, and now Docker container. So one process per container. Don't have multiple things running in there, because when that process dies, the container dies. Don't get attached to your ports. Don't hard code ports, port bindings. Get them out of the environment. Bind to whatever port you're told to. You're not going to get the port you want all the time, and it's okay. Concurrency, yeah, we're going to scale you out, and you better know that if there's other instances you're running, you better run correctly. You need to come up fast and go down fast because these containers are going to come and go. So disposability is important. Dev prod parity is really important because, we want to make sure that what's running in production is as close to, or what we're running in dev was as close to production as possible. Log to standard out. We don't want to log to files anymore because when a container dies, the log files go away. And so you want to log to standard out and then stream that log somewhere else. And then admin processes should be part of your application, not some script, in somebody's pocket. You deploy the whole thing together as a one-off, and then you initialize your database, seed your database, whatever you're going to do. And then we want to use a consistent way of communicating with REST APIs, right? And so we want to use verbs, HTTP verbs, right, to communicate in a client-server paradigm. Stateless. Every request has all the information you need to make the request. They can be cacheable. The key thing is that they're uniform and that they're layered. You only see one layer. You don't have to worry about layers beneath it. So you're going to use these get, put, post, and delete verbs. Here's an example of a REST API. So I do a get on customers. I get all the customers in the database. I get a get on customers 1, 2, 3, 4, 5. I get that particular customer. If I say customer ID / orders, I get all the orders for that customer, and customer ID, order ID. I just get one order for that customer, right? So it's a very predictable way of describing it. You don't want to put action words, not get user, add user. It's implied by the verb that you use. So the correct ones are on the bottom: get users, post users, delete users. You don't have to change the name of the API all the time. So if you haven't guessed yet, get's a read, post is a create, put and patch, do an update, and then delete, of course, does a delete. I'm gonna skip over these because there's just not enough time to go through all this stuff. Important that get doesn't have any side effects. That I can do get all day long and it's not going to go modify the database. It's only going to read. And then post is not idempotent. Post is, if you hit post 3 times, it's probably going to create three things. Using headers, queries, right? Using query parameters for queries. Proper return codes are really important. So you're going to see in the code there's using 200 and 201 for a create and 204 for a delete. That's just more detail on the return codes. And then, of course, getting them back should get a return code and some object, right? An array of users, one user, that kind of thing. Okay, what I want to do quickly is deploy the version that has the REST API. So let me hit Control C here, and then move up to that one. So here's the RESTful counters. And let me show you. We can copy. Let's copy. It's okay. Let's copy. I don't think this one changed at all. Yeah, it did. So I added a log handler because it started to get complex, and so we want to paste this log handler in our code. The log handler was already in the code that I gave you. These are the new routes, and we'll paste those into our routes. And then let's just go get the new tests, and I'll explain what each of these are. We'll put these in the test service. So what you'll see is happen now, and let me just go close a bunch of these. Let's get the routes here. So in the routes, you'll see that counter call wasn't very RESTful. It was. We want to use the plural because it's a counters collection. It's a collection of counters. And so listing all the counters, I do a get on counters, and it goes through and creates an array, just using a list comprehension here, going through all the keys in the Redis database to get the counters. And creating a counter now by name, you pass in the name of the counter you want to create. It goes and checks to see if the name already exists. And if it does a 409 conflict. Right? Sorry, I can't create that object. It's in conflict with another object. So I send a 409 conflict back. Otherwise, I do Redis set to set a new variable, and I initialize it to 0. And then I send back a location header with read and a 201, and of course the name and the counter comes back. So for read, I just have to go get the counter from Redis. If it doesn't exist, right? If I do a get and Redis sends me back none, then I send back a 404. not found. Otherwise, I already have the counter here, right? It wasn't none. So then I go give it the name that it passed in, and then the integer version of that counter, because Redis stores everything as a string. Every scalar gets stored as a string. So you have to cast them back and forth. You have to be, you know, I mean, Redis was meant as a fast memcache, right? It's an in-memory database that has persistence behind it. So I had to cast that back to an int. And then to update a counter, again, I read the counter. If it doesn't exist, 404 not found. If it does, I call the increment function. So in this particular one, every put is going to just go increment the counter instead of the get. Why? Because get shouldn't have side effects. So we learned that the REST API that we had, the API we had before wasn't RESTful because it was updating on a get. It shouldn't do that. And so get now just gets the counter. And if you want to update the counter, you do a put, which is an update. So that increments the counter. And then again, I have my little reset counters, but this time instead of counter equals 0 or set to 0, I have multiple counters. And so I do a flush all, and the flush tells Redis to flush all the counters out of the database. And then in the tests, if we go through the tests, you can see that I've updated a lot of the tests as well. So we still have the create. Now we have a list where we can list multiple counters. We can read a counter. So again, I'm doing a post. I have to create one first. So I'm doing a post to create a counter with a name. And then I'm doing a get on that counter, that same name, making sure I get back a 200, and then getting the JSON and make sure I got that and it's 0. Right. And then if I update a counter, I can go do so I can do a post, get it back, make sure it worked. Then I do a put. That's going to increment the counter. So the first time I check if the counter is 0, the second time I check if the counter is 1. And if I run those tests down here, you'll see that there's a couple of more tests, listing and reading and updating counters, and I've got 92% code coverage. All right, we were going to do Travis CI next, and then Docker and Kubernetes. So let me show you Travis briefly. So continuous integration is continuously integrating your changes. So instead of working in long branches, whenever we make a change, we do a pull request, and that pull request gets merged into master. So that's continuous integration. And usually test get run, test pass merged into master. Continuous delivery is then deploying that somewhere, right? So that's the difference between CI and CD. Now, in traditional development, they work in these long branches. And these long, you may push code and push code and push code, and it doesn't get merged for like a month. And that's really, and then that's why merging has a bad name, right? It's like it's a nightmare to merge the code. Yeah, you let a month of changes go by, it is a nightmare. But if it's only a couple of hours of changes, it's pretty easy to merge. Usually there are no merge conflicts, and when there are, they're usually small. So we want to continuously integrate our code. We make a branch of the feature, we merge it back. Another branch, we merge it back. Yeah, occasionally there are conflicts, but the conflicts are usually just a couple lines of code. And then we fix it, and then we keep going. So it's a much, much better way of working. So everyone commits to the baseline, right? So you're committing your features, you're merging into master, and the pull request allows you to communicate about changes. And then somebody approves it and it gets pulled back in. So, instead of it being emotional, right, delivering this stuff, you want it to just be continuous, right? You've got some nice, flowing stream of commits that people aren't getting upset about. But that gives you faster reaction times, reducing the code integration risk, right? And you get higher code quality out of it. So now to do this, you need a repository, right? So we have Git. You need a build server. We're going to use Travis CI for that. You may need an integration server as you get bigger. And when I deploy to IBM Cloud, I use integration services in IBM Cloud. You might need a repository to store binaries. Now with Java, this is where you'd put your jar files, your war files, your ear files. You could make Python wheels and store your wheels there and stuff. Use something like Artifactory or Nexus. And then, a tool to automatically configure all this in a pipeline. So continuous integration is this plan, code, build, test continuously. And then continuous delivery is releasing it somewhere into the cloud, into Kubernetes, into some server somewhere. Now, you might hear continuous deployment. I wish they had called it continuous release, so at least it would be CI/CD/CR. It's tough when two Ds are the same thing, but when people use continuous deployment, they usually mean deploying to production. So they reserve continuous delivery for delivering internally to prod, to test, and to stage, and to dev. And then when we deliver to production, they call it deployment. It's a nuance. I don't like it. I'd rather it was called continuous release, and then we'd have a CI/CD and CR. But sometimes you hear the Ds are different. You could use many tools within an organization. The only stipulation is that you use tools, right? You automate this. Don't do all this manual. But automation is not sufficient on its own, right? Your application design has to allow for this. Allow to do testing of little components and stuff. Okay, so there's lots of tools: Jenkins, Circle CI. We're going to use Travis. So for doing continuous delivery, right, master branch should always be deployable, right? Whatever's on master, I could always deploy. And then test cases are critical to know if you broke production. So it's really important. Travis CI supports lots of languages. Your favorite language is probably on here, hopefully. It supports lots of databases. So you don't even have to deploy a database. You can say, hey, Travis, I need a Redis database. This is what we're going to do. And it will go off and it'll create a Redis database for your test and then break it down after your test. Now, so Travis has changed from travis.org to travis.com. And I unfortunately have an old account, so some things might be wacky with mine. I would suggest you try travisci.com, which is the newer one. I did that and got it working, and then I saw some of my Travis org stuff in there. So you might see some weirdness with me, but travis-ci.com, you can create a free account, you can link it to your GitHub, and then you make this little .travis YAML file in the root of your project. So that's what we're gonna do now. And this is an example one. So you tell it the language, what version of the language. Notice that's a list. You could have multiple, I could say 2.7, 3.5, 3.6, 3.7. It'll do parallel builds using all those different Python languages. It's great if you write libraries and stuff, right? Because you want your library to work with a bunch of languages. Then you do, what do you want to install? We do pip install requirements. You want to run something before script. I always ping Redis to make sure it's up. So when I'm debugging and I can't connect, did the ping work? Oh, the ping worked. Maybe my code is broken. Oh, the ping didn't work. My code's probably fine. The Redis server is not working. And then the script that you're going to run, right? Run your tests or whatever. And the fact that I need a Redis server. It's got a lot more. It's got before install, before script, after success, after failure. It'll also do deploy. We don't use it for deploy, but it'll before deploy, and then after deploy, and after the whole script. So yeah, my old screenshots say travis.org. I would suggest you go to travis.com. That's what I'm going to do. Sign up with your Git account, and then you have to authorize Git. And then you'll probably come to a screen like this where there's nothing on it. And then you hit the little plus to add a repository. And then you can scroll down, find your repository. Yeah, this is a few. Yeah. So this is the one I use in school, Lab Travis CI. You're obviously going to look for DevOps-Workshop-2020 in yours. And I'm going to take you there in a minute. Flick the switch. Oh, the switch is only on travis.org. So you might have a switch on travis.com. So these are the differences I'm noticing in this as I started to transition over to the new one. But then you'll be running the build, and then it defaults. I don't change these defaults. It defaults to push to doing branches and pull requests, and that's fine for me. That's what I want to use it for. You can create a badge to put on your page, and we're gonna do that. You just take the markdown, cut and paste it, and then put it in your README file. So let me go to well, first let's get the code to where we need it to be. So in this one, all I need is the next one, which set up Travis CI, and that's just the Travis YAML file. So all you need is this Travis YAML file. So you could literally take this and say copy, and then scroll down and tell it to paste somewhere in here. Paste. And I copied it there. Drag it out. Please stop. And then rename it. I hate when UIs don't do what I want. And people wonder why I use the command line. So I put a little Travis in my root. Here's a different way to go make a branch. So now I'm gonna click on master if you're using Visual Studio Code, and then you can just say Travis CI is the name of my new branch. It'll create a new branch. I think I put an equal sign in there. Didn't mean to, but I did. So now I'm on this branch called Travis CI. And here's my Travis file. So I'm telling it I want Python 3.8. I need this Redis server, right? So how did I know it was called Redis server? I went to their website, I looked up the databases, and it told me to put, and I literally cut and pasted from their website. I set a global variable database. Actually, I didn't have to do this because the code will default to looking on localhost. So this could have been omitted, it would still work. But if you wanted to use some other Redis database, you could set it here. Then I do just a pip install requirements. I do my little ping. I run nose tests. I commented out code coverage because I'm not using it today, but I use it with my class. So that's all we need to go. So now for committing inside of Visual Studio Code, you could do what I did last time, but if you come over here, it'll show you what's changed. I have one stage change with routes.py, and it's telling me I changed Travis, it's brand new. I've changed the init.py, that one's brand new because I cut and paste it. Here are the changes I made from my app.py to my resource. So it shows you all your changes. Really, I think this is really, really cool. And you can see just what changed since the last time you committed. And then I can go up here and click the plus, and it will add all those changes. Just so you're not confused, that is exactly the same as saying git add, dot, right? Just add everything. So it's just taking the place of adding one at a time or doing git add dot to add them all. And now I'm going to do a git commit. So doing a commit is the checkbox. So I'm going to say added Travis support. Oops. Add Travis support. And then clicking the checkbox is going to do a commit. So that's an alternate way. And then you want to do a push. You could just open the three dots here and you say push, and it will say, hey, you don't have a remote branch. It gives you the same error message as Git does. Hey, there's no remote branch. You're like, yeah, publish anyway. Now there is a publish. And now because I have two, it's asking me origin or upstream. You're not going to get this because you only have origin. So now it's going to push that branch up there. And let's go look at my DevOps and refresh the screen. So now I have recent changes, compare and make a pull request. And again, I've got to change it and tell it I want to go just to my IBM one. So you want to go to your personal one. Be careful with that or you're going to send them to me. People always send them to me every time, so don't worry. I just delete them. And there used to be I got to find out what happened. There used to be a button that said link an issue. And you could actually link the issue, and the issue got pulled over with it. I'm not sure why it's not showing up, but I don't have time to debug it. So I'm going to create the pull request. Now, I already connected mine to Travis, and mine are running. So let me go over to Travis. I'm going to go to travis.com. You would have to sign up for this. So now you can see that it's running. Here's the little plus to go add your repo. So if you went to Travis and signed up, you click a plus and you can add your repo. So now you see a build on my DevOps Workshop 2020 is now running. So yeah, if you hit this button here, it'll show you. So here's the thing, right? My account on travis.org, it wants me to activate it to get it to travis.com. But here are my organizations. So I could just click on my IBM DevOps and I've got my DevOps Workshop, all set up. So that's why that one is running. So let's go back to Travis CI and watch it run. And so here you can see these will collapse as they execute. So here it is. It ran all my test cases and all the test cases passed. It exited with a 0 return code. And so if I go back to my pull request, I could see all the checks have passed and I'm able to merge that pull request. So nobody should ever merge a pull request when the checks have failed, right? You go back and again, if you go to approve this, 5 files have changed. It shows the files that have changed. I changed some stuff in the init. I changed some stuff in the routes, right? So you can go do a little mini review. I actually changed more than I should have here, but I just wanted to show in the interest of time. So now I can merge that pull request and confirm the merge. and it's going to do that merge to master, and then I go delete my branch. So I've got the branch done, and then I'm going to go back to, we'll do a git status, and we can do this the old way. So now I'm going to do a git checkout master, git pull. Just thinking about that one. Right, so there, app.py was changed, service init.py, right? So Travis was added. So that looks like the right pull request. Do a git branch. And then I do a git branch delete Travis CI equal sign. And that deletes it locally. And then, as I said, and I think this was the question that was in the chat, that the remote branch was still there, and you should be able to do a git remote prune origin, and then it should be gone. So that was example of Travis. Okay, so now I'm going to go through. I'm going to go through Docker really quick, and because we're running out of time, I apologize. It was maybe a little bit too much to pack into 3 hours. But again, perfect storm. We're on to containers. We'll talk a little bit about Docker. So, what is this lure of containers, right? The shipping industry used to, bespoke ship all this stuff, pianos and cars and sugar, and they try to pack them into who knows what they try to pack them into. And then in the 1960s, they came out with this notion of, hey, if I made this container and I built ships that could take tons of these containers, I don't care what people put in the container. And then I just got a ship that knows how to, ship these boxes. And so Docker is kind of the same thing. It took this notion to say, hey, if an application developer can give me all their dependencies and put them in a Docker container, then I can deploy it anywhere, and it just works. So that's kind of the lure of containers here, right? So Docker is a platform for encapsulating all your code into a runtime and then deploying it the same way every time. So they're very lightweight. They share the Linux kernel. There are also containers for Windows now, so I should update this. But most of them were running on Linux, and it's almost no overhead to start up. And they give you great isolation. They're easy to manage, right? They encapsulate the implementation. So you can create images, containers from Docker images, other people's images. You can create your own images. You can add stuff to the images and run them. You get them from Docker Hub, and then you can deploy them. Again, it solves this, runs on my workstation. Don't know why it doesn't run on yours. But containers are different than virtual machines, right? They're much more lightweight. A container is a process. It's an encapsulated a virtual machine is an entire operating system. A container is just a process. So I know it might look like a virtual machine, but it's just a process running encapsulated. So virtual machines are entire runtimes with binaries and libraries, and containers share the host kernel. They're not separate kernels. They're not separate guest OSs, and they're just the binaries and the applications running on top of them. So you pull them from Docker Hub. If you do a Docker pull and it's not there, it'll go get it from Docker Hub. If it caches it on your workstation, the next time you run it, it gets it off your workstation. Again, the image, it's kind of like running virtual machines. The images are like AMIs in AWS. It's the image that you start from, and then you add memory and stuff, and the container is the alive thing that's running, the instance that's running. You get them from Docker Hub, so you can get like Nginx and run it, and not have to install it or anything like that. I mean, that's kind of the beautiful of it, right? We got this Docker run, Nginx Alpine, and let's just do this one. Let's just break out and do this. So go to your command prompt, right? Go to your command prompt. And let's do a Docker run. Whoops. Docker run. I'm going to do --rm for remove. I don't want it to run as a daemon. I want it to run in the foreground. So Docker run --rm, and then I want to say I want to forward a port. P is to forward a port, and I want to forward port 8080 on my workstation to 80 inside the container, and I want to run Nginx. and the Alpine version because it's nice and small. So Nginx Alpine isn't there locally. Something already exists, so it's a layer that already exists, and now it's running Nginx. It pulled down Nginx, and so if I go to a web browser and I go to localhost 8080 with any luck, instead of 5,000, we're going to go to 8080 this time. With any luck, boom, welcome to Nginx. I didn't have to install Nginx and have to know anything about Nginx. I got Nginx up and running like that. So that's the beauty of running these containers, right? So as these portable, isolated environments, here's the famous, 5-minute MySQL, install. What they don't tell you on step 2 is, your WordPress install. But on step 2, you got to install MySQL, which is another bunch of steps, right? So it's not 5 minutes. But in Docker, it's, Docker run a MySQL database, Docker run WordPress, link it to MySQL, done. 2 commands, and you've got WordPress and MySQL up and running. It's really remarkable. So, when you do traditional deploys, and this is kind of important, right? Normally, I'm developing an environment, I push to GitHub, and then the build is running on a build server, and maybe it's got the same version of Postgres, maybe it doesn't. And then I'm getting deployed, and I deployed in production, and whoa, there's Redis in there, and there's Nginx, and there's all sorts of stuff I don't have on my workstation. I have no dev prod parity, right? So when I have containers, the developer can run Nginx and Redis and Postgres and everything on their workstation, push the code to GitHub. The build server has the same version of everything. It pushes a Docker image to a Docker registry, and then that Docker registry pulls it down to run it hopefully in something like Kubernetes. The same container that's running on the developer's workstation is running in production, dev prod parity. So it's really, really important. It's a very powerful, powerful concept. Okay, so we're going to create our own Docker image for our application, and then we're going to run the application from Docker. So let me go back here. Sorry. Let's go back, and we'll go back to our over here to our code. All right. And so what I want to do, I'm going to close all these. I'm going to go to open editors and just close them all. Get all the editors closed. So I want to come here and a new file, and we want to call it Docker file. That's going to create a Docker file. And then we've got to create it from some image. So I'm going to say from, and I'm going to use Python 3.8-slim. Now, how did I know Python 3.8 slim other than my editor is kind of suggesting it? I went to hub.docker.com. I searched for Python. I found the name of the Python image I want. This is the one I always use. And so now it's just like in my head, but I found it on Docker Hub, right? I went to Docker Hub. Let's go to hub.docker.com. I search for Python. Get a bunch of Python images. Going to start with the official one, and then I scroll down, and it said, look at all the Python 3.10, 3.9, 3.8, 3.6, blah blah blah. You just pick one of them, right? You pick one that you want, and you're off and running with it. So we're gonna let me do Control C. So go back to where you ran, if you ran this, and do a Control C to get out of Nginx here. So from Python, I'm going to create a working directory. I'm going to call it app. So that establishes a place to put my code. I'm then going to copy requirements.txt, requirements.txt. And I'm going to copy it to dot, and it's going to go into app. So I'm going to copy it from the side here, and I'm going to copy it to app, and then I'm going to do a run pip install -r requirements. Then I'm going to copy the rest of my code. So then I'm going to copy the source folder /source. Now, why did I do it this way? Well, I could have just copied the source and then pip install requirements. Although requirements.txt is not in the source in this case, but what I want to do is I want to take the things that change the most and put them at the bottom of the Docker file. And so, because Docker's a layered file system, so as soon as it has a miss in the cache, it rebuilds everything. So I want to establish all my dependencies and then add my code. And then when I build it the second time, it's going to take all the cache dependencies, just reuse them. It's not going to reinstall. And then it's just going to copy my new code into the container, build a new container. And then finally, the command to run it. So what I used was I included something called G-Unicorn, which is a green unicorn. It's a production WSGI server for things like Python. So I'm going to G-Unicorn. Right. So you're saying, well, where is that coming from? All right. All right. So requirements TXT, I installed it. Right. It's one of my requirements, G-Unicorn. So the back of my Docker file. So G-Unicorn, and I want to tell it -- bind. And then that's 0000. That's the G-Unicorn one. And then I have to tell it service.app, right? I have to tell it where. I'm sorry, service:\app. I think that's all I need to get that running with G-Unicorn. I'm going to save that. And then we're going to build it. So we say Docker build. We have to tag it -t, and I'm going to call it hit counter colon 1.0. So it's it's not hot counter, it's hit counter. Hit counter 1.0. So it's going to be a tag, a colon, and then another tag. So the name of the image, and then colon, and then usually people put the version number. In the case of Python, they put 3.8-slim. So I'm just calling it 1.0. And then where do I build it from? Period. Build it from the current folder. And then this is going to go build it. So notice it's saying from Python. You can see here it's going from Python, create a workdir. There it's installing. It's doing all the pip install stuff. Right? All this stuff is running. After the pip install, it's going to copy my source in. And it's done, right? It's no such file. So did I copy source failed, mail attempt out of no such file or directory. Okay. So this is why we create backups. Oh, it's called service. All right. Silly things, silly demo things. Service is the name of the folder. You're probably screaming service at me, but I can't hear anybody. This is the nice thing, the bad thing about not being in a room together. Service. Okay, now watch. Now, it's not going to go build all those requirements again. You're not going to see all that pip install stuff again. I'm going to up arrow. Let me clear the screen. Open up my sleeve. Up arrow, hit it, and it's going to go cache. Ooh, let me add your code. This is why I don't add the code and then build the requirements. And then every time I make a change to a README file, it's rebuilding your requirements. It's crazy. So there's my hit counter, okay? So now my hit counter is running, and I'm going to actually run this in a Docker container. So let me do Docker run. Maybe it's easier if I do these, I'm sorry, in a bigger setting here. So I apologize. Docker. So now if I do Docker images, I can see I've got my hit counter 1.0 image. I've got the Python image that I used to build it. That got pulled down. I have Nginx because I played with Nginx, and I have Redis because Redis 6 was installed from the Vagrant file, right? So now I've got my hit counter image, and I'm going to say Docker run -- remove. And then I want to open up the port. So I want to say 5,000, right? So that's forwarding the port from inside the container to the port on the VM. And then the VM has its port 5,000 forwarded again to my laptop. So that's how I'm going to get to it from outside the laptop. And so Docker run, the name of the thing. So hit counter. How to spell it right. Hit counter version 1.0, right? So that should, there it is. It's up and running. Oh, it's listening to port 8,000 because I didn't expose the right port inside the container. So that's not good. So as long as it's doing that, I'll buy that. So let's say, okay, forward 8,000 to 5,000 then. More than one way to trick this, right? Now let's see if I did this correctly. I'm going to go over here and I'm going to say Docker PS. And it's saying that 8,000 is being redirected. See over here, 8,000 is being redirected to 5,000. I always get them mixed up because in Docker, the port number, guest host, is opposite of Vagrant. And so I never know which one's which. So now this should work. So I should be able to go to localhost here and go back to 5,000. Can't open. It's not happy. Okay, so let's go to 192.168.33.10, 5,000. Maybe I did get it backwards. No, it's not happy. It's still not happy. So let's try it the other way. This is what happens when you go off book. you go rogue on the demo, but there we go. It was the other way. So there's my hit counter service. Let me make this bigger for you. There's my hit counter service. And if I call counters, it blows up. So why does it blow up? Because it was working before, right? It was working with Redis. It was giving me the counters. Well, here's what's happening. Let me just show you. Sorry. So what's happening here, this is why I kept these here. I kind of went through all this stuff with you. Oh, right. So what's happening is you were running Docker on the VM, and Redis was being exposed on localhost. I'm sorry, you were running your app on the VM on localhost, and it was being exposed on localhost, and you found Redis. When you put your app in a container, it wasn't running on localhost anymore. Redis is still talking to localhost. So we have to link the two of them together so that Docker knows what to do. So let's do that, and that'll be the last thing we do because we're at the top of the hour. So let's do that. So now when I start it, I'm going to say -- link Redis, and then I'm going to inject an environment variable. I'm going to say -e database URI equals, and it equals Redis // and then Redis is the name of the container. I think that might be enough, but 6379. And let's go back and refresh. It's still not happy. It's still trying to connect to localhost. So maybe I typed something wrong. So hang on. I spelled database wrong. You got to spell the environment variables right. The applications are real bad at guessing my bad spelling. Okay, so let's try it again. Oh, there we go. Counter foo. So this was a little. So this one we kind of missed it, but we added code to do multiple counters. So now the counters have names. That was kind of that name that was come in, right? And so I can do this all day long. All I'm going to get back is that counter foo. If I want to get back something different, then I'm going to bring up Postman and show you how you can make a post to this. And then we have 2 minutes left and we're done. I'm sorry this is taking. It was a lot of material to cover. We covered a lot of technology. Hopefully you have enough. Let me go see if this if this works. Oh, this is on 5,000. No, not found. Well, why was that get not found? Counters. Oh, I'm surprised. Hang on. Yeah, 5,000 counters. Why am I getting 404 not found? Okay. Counters. Let's do a post. Oh, I didn't put the 5,000 in there because this URL was from Kubernetes because I was using an ingress. So now I'm going to do a post, and you notice a post. I can't do a post on counters without giving it a counter name. So foo, and now it comes back with foo already exists because I'm trying to create a new one. So I'm going to create a bar. We'll create a different counter, and bar comes back, right? And then I could do a get on bar, and I should get back 0. And then if I do a put on bar, I get back. You're watching down here. I get back a 1. I get back a 2. I get back a 3. I get back a 4. And then of course, if I do a get, I'll get back the 4. Right. So we've successfully implemented. And there you can see the request. This is why I added the logging and stuff. So request to read, request to update, all of these requests. Okay. Yeah. Okay. We're not going to have time for Kubernetes. I'm really sorry. I really need to cut this down. It really should be a 4-hour. Next time we're going to do 4 hours. Is there any question? Do we have time for questions, or we're just out of time? I'm sorry
I
about
have maybe one question. Is anyone has a question?
I know it was a lot to hit you with.
No, it's fun. I mean,
It was a fire hose. If I had another hour, we'd do Kubernetes, and I'm sorry. The thing about preparing for a 3-hour workshop is it takes 3 hours every time you try it. There's only so many 3 hours in a day. So I apologize for running out of time, guys.
It's just a lot of material, yeah, to go.
Yeah, it is. I got to cut it down. I'm working on cutting it down.
No problem. I see no questions, so maybe we just thank you, give you a big applause.
Thank you. Yeah.
Thank you.
Thanks much. Come to NYU, take my class, get 15 weeks of me.
No, I'm going to invite you back to my class. You have
a
50 students sitting there, and that can be Zoom. That can be much easier using Zoom. Yeah.
Very good. Very good.
All right.
Thank you so much, everyone. I appreciate it.
So I'm going to finish this one. Okay, good. So I'm going to stick around.